Hey guys, welcome to 2025 May June paper 2. As you know, the fact that this entire document is going to be available in the membership. So you're going to get this whole document, which is like 142 pages, but it has everything that you need. So it's going to be basically the video, but in the PDF. So if you want to follow along and you don't want to write, this PDF has everything. Just one more thing is that there's a couple of questions in paper 2 that requires you to like use calculator for statistics. Is that I'll link videos for that. And also for Euclidean is that there is the proof question. I didn't do the proof question because I already have it in my master series. So also I'm going to link the video to that. But to make it a little bit easy for you guys is that I made sure just to link the parts, especially for the stats, the entire video. No, yeah, for the stats it will be the entire video and also maybe the portion that I'm talking about in terms of the calculation, so that you don't need to go through the whole video. And also for Euclidean it's going to be the same thing. Just wanted to say that as you'll see in the video, is that some things I can't go deep because of one, I need a calculator, and the other one, it's repetition. So it's already in there. So just wanted to say that. And also this PDF is going to be available in the membership, and I'll just show you on how to get the membership portion part of it. Anna. So that will be how to join the membership. So now how to get the PDF version of the video, right? Is that when you go under my page, is that you'll go under post, right? So post, you're gonna have just members. Do you see the fact that this is only for members only, meaning only you guys can see it? So but if you click on membership, right, if you part of it, right, but if you're not part of it, you're not going to be able to see it. Is that recent members only? So you're gonna go here. Then when you go here, you will see the fact that this is the post regarding this video. And obviously for if it's a different video, right, is that you will get the same post. But when you click on it, and let's click on Chrome, you'll say the fact that it's gonna load. Then it's gonna tell you the fact that which paper it is. Then it's gonna load, right? Then when it loads, this is the actual PDF. Do you see it? This is the actual PDF, and it's exactly how the video is. So you don't need to write notes. If you download this, you are sorted, right? So this is it, and yeah, that's it. So now we're going to do question 1. So question 1 says, an insurance broker signed a contract with 15 people. The monthly premium in rands are payable on each contract is given below. So this is the monthly premium, right, in rands. So the first one, it says in what you call 1.1, it says calculate the mean of the data, right? So calculating the mean, the formula for mean is going to be X bar is equals to the summation, right, of all the premium. So I'm going to be sum of all the premium, right? So all the premiums, right, divided by the total. So how many? So divided by the total premium. Right, so we first need to add all of them. So this is going to be like this. So this is going to be equals to 134 plus 215, right, plus 325 plus 326 plus, I'm just going to say dot dot dot, meaning we adding each term. So we adding this, 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 and this. We adding all of them, right? Then I'm just going to do the last 3 numbers, which is going to be 923 plus 100 and 1034 plus 1200, right? So this whole thing divided by what? Divided by the total. So the total is 15 people, right? It's 15 people, but you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 15, so it's divided by 15. So when you sum all of them, right? When you sum all of them, you're going to get the fact that the summation of all of them is going to be equals to 8,554. And this is going to be divided by 15, right? So therefore, when you punch that into the calculator, you're going to get that your mean is going to be 570, comma 27, right? So that's your average. So that's going to be your x bar, which is your mean. So now what we're going to do, we're going to do 1.2. It says write down the standard deviation. So I already have a video under stats, mastering stats, so showing you how to do it on the calculator. It's going to be there. So what I'm going to show you, this is the steps, right? So if you have the PDF version, is that these are the steps. So using the steps, right, is that, and also I'm going to link the video in the description, so it's going to be fine if you don't, basically you're struggling using the calculator. Here are the steps in like detailing everything, and also there's a video, right? So you're going to be okay. But is that after using all the steps, right, and using your data, is that your standard deviation for this question is going to be what? It's going to be the standard deviation, right, is going to be equals to 291,03. So after using the steps, right, and also watching the video, applying it, obviously using this data, this is what you're going to get, right? So that's that. I can't show you because of I don't have a Casio right in front of me, but I already have a video detailing everything. So that is how you would find the standard deviation. And also, as I said, this is the steps for that, right? Hope that makes sense. Okay, now what you call is doing 1.3. It says calculate how many monthly premiums are within one standard deviation. So do you see the fact that there's one standard deviation? I'm going to just give you a formula. What does it mean to say one standard deviation? So one standard deviation, this is the formula that you need to use, is that you need to first find the range of one standard deviation, which is going to be x bar minus, right, x bar minus the first standard deviation. So this is the first standard deviation, right, and x bar plus the first standard deviation, right? So if they said the second standard deviation is that this one was going to be replaced by 2, if they say the third, continuously like that, right? So maybe let me just do this. Let me give the general form, right, so that next time you know how to use it. So let me just do this. So the general form of maybe 1 standard deviation, 2 standard deviation, and all that, this is going to be the general form, right? So this is going to be x bar, right, minus n standard deviation. That's going to be x bar plus n standard deviation, right, where n is an element of integers, meaning it's 1, 2, 3, 4, 5, right? So like that, right? So now in our case, this is the general form, right? So this is going to be the general form. Let me remove this n. Doesn't matter because I'm going to explain what n. So n represents 1, 2. When they say 1 standard deviation, meaning n is equals to 1. Hope that makes sense, right? So now this is in red, right? So we're looking for 1 standard deviation. So meaning 1 standard deviation means that n is equals to 1, right? So now using the formula is going to be x bar, right, minus 1 multiplied by the standard deviation. That's going to be x bar plus 1 multiplied by the standard deviation, right? So we know the fact that x bar, we have calculated it previously, is equals to 570. So we know the fact that that is going to be 570. So it's going to be 570,27. And we know that the standard deviation, right, from our calculations is what? Is 291. So it's going to be 291, comma what? Comma 03, right? So now let's substitute. So this is basically equals to what? It's going to be 570,27, right? Minus what? Minus 291,03, right? And it's going to be 570,27 plus 291,03, right? So when you punch this into the calculator, you're going to get the fact that it's going to be what? It's going to be from 279, right, comma 24 till where? Till 861, comma 3, right? So that is our range within 1 standard deviation. But the question says how many. Do you see the fact that how many monthly premiums? Is that we need to basically check how many premiums within that, right? So we need to look from the data. Okay, so I took the data, right? So from our data, we need to look at which premium lies between this, right? So we see the fact that our starting is from 279 going till 861, right? So we see the fact that this one, basically, I'm going to highlight, right? This one cannot be, this one can, okay, so this one cannot be part of our range. This one is not part of our range, right? But this one is part of our range. So the one that's part of our range, I'm going to highlight. So this is part of our range. This one, 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 right? But we see the fact that this is also not part of our range, and this one is not part of our range, and this is not part of our range. So we're gonna count how many of them are part of our range. So we see the fact that when we count them, right? So we see the fact that when we count them, so let's count them. This is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total is 10 premium that are within the first standard deviation, right? So this is going to be what? It's going to be a total of 10. So a total of 10 premiums. So that's going to be your answer for this question. So now we're going to do 1.4. It says the company insurance decides to increase the premium, the monthly premium, right? So they tell us the fact that the monthly premium that are less than 500 Rand, right, increase by 10%. So everything that's less than 500 Rand increase by 10%. So let's show that, right? So everything that's less than 500 Rand is going to be increased by 18%. So I'm just going to block everything that's less than 500 Rand. So it's from here going till here. This is less than 5, right? So that is less than 5, right? I'm going to make it in yellow, right? So that's everything less than 500 Rand, right? So this is going to increase by what? This portion here is going to increase by 18%, right? So that's going to increase by 18%. Then they tell us the fact that everything that is what? That is monthly premiums that are equal to and more than 500 Rand equal, this is going to increase by K, right? So from here, going to here, they're going to increase by some K, right? So it's going to increase by K, right? So we know the fact that this is going to increase by K. So it's going to increase by K%, right? So to correspond, we're going to highlight this is going to be increasing by K, and this is going to be increasing by 18%. So hate this. So this is going to be yes, and this is going to be like this, right? So now what we need to do, then they further tell us the fact that after those increase were applied, so meaning those increase were applied, right, into the above data, the new mean for the monthly premium is now this. So the new mean, so we know the fact that the new mean, right, so let's call it X bar. So the new X bar, right, is equals to 686,44. Then they say the fact that we need to calculate what? We need to calculate the value of K. So going back, when calculating the mean, what do? We add up. So let's go back, right? When calculating mean is that we add up everything that we have, right? Then we divide it by the total, right? But here is that what we need to do is that we need to add up everything that is less than 500 Rand, or premiums that increase that like everything is less than 500 Rand, because we know the fact that that is going to be affected by this 18%. Then we need to add up everything that is greater than 500 Rand, because it's going to be affected by this K, right? So this increase, right, I'm going to represent it by the following, right? I'm going to represent this increase so that the calculations of me doing everything is a little bit easy. I'm going to represent this 18% by this, which is going to be, it's going to be the same as 118 divided by 100. I'm going to represent it by that. And also I'm going to represent the increase of k by this, which is going to be k plus what? Plus 100 divided by 100, right? So what I did here and here's the same thing. Here is that I already know the fact that the percentage is 18. So I took 18 plus 100, which I know the fact that's going to be 118 divided by 100, and I did the same thing here. This is so that it's going to be easy for us to calculate our percentage, which is k, right? So now taking that into account, we need to add up this term because we're looking for the mean, right? We need to add up these terms, right? Multiply by the increase, then we need to add up these terms and multiply by the increase. So let's do that, right? So we're going to start with the yellow part, right? So when increasing, calculating that is going to be what? It's going to be less than, let me call it, yeah, I'm just going to highlight it, right? It's going to be the following. It's going to be the sum of the yellow. So the sum of the yellow, which is going to be 100. So sum of yellow, right, it's going to be what? It's going to be 134 plus 215 plus 325 plus 326 plus what? Plus 362 plus 429, right? So the sum of that is going to be equals to what? It's going to be equals to 107.91, right? So we know that, right? So now we have the total of the yellow, then sum of green, right? It's going to be what? So I don't want to just add them like that. I already know the fact that if yellow is equals to that, and we already have the total, right? Remember the fact that when we were finding our mean, we know that the total is 8,504. So I can just subtract my yellow to get my green. So it's going to be 8,000, right? So it's going to be 8,000. We know that the total of everything. So what I'm doing is that I'm taking the total, right? Then subtracting the yellow to get the green. Hope that makes sense, right? So I know that the total is 8,504. Then I'm subtracting the yellow, which is 1,791. And I'm going to get that my remaining, which is the green part, is going to be what? It's going to be equals to 6,763, right? So now we know that the mean is adding them up, right? Divided by the total, and it's equals to the mean, and we're looking for k, right? So meaning now to find k, it's going to be what? It's going to be the summation. So we know the fact that it's going to be the summation of yellow, which is going to be 1,791 multiplied by the increase, and the increase is going to be 118 divided by 100, right? Then this plus the summation of the green multiplied by the increase, which is k, right? So it's going to be what? It's going to be 6,763 multiplied by the increase, which is going to be k, right? Plus 100 divided by 100, right? Then this whole thing, remember the fact that we finding the mean is going to be divided by what? The total, which is still 15, right? And it's equals to the new mean, right? The new mean is 600 at what? 686,44, right? And now we're going to solve for k. So let's do that, right? So we're going to take the 15 to the other side. So this is going to be 1791 multiplied by 18 divided by 100 plus 67, right? 63 multiplied by k plus 100 and divided by 100, right? Is equals to 686,44 multiplied by 15, right? What I'm going to do is that I'm going to take this to the other side so that we can have this alone, right? So that's what we're going to do. So we're going to have 6763 multiplied by k plus 100 divided by 100. And this is going to be equals to 686,44, right? Multiplied by 15, right? And this is going to be what? This is going to be minus what? Minus 179,1791 multiplied by 118 divided by 100, right? Then now this side we're going to have it like the way it is. So it's going to be 6763 multiplied by k plus 100 divided by 100. And this side, we're going to punch this entire thing. So let me take it. We're going to punch this whole thing into the calculator. So punching that whole thing into the calculator, you're going to have what? You're going to have 81. So when you punch that into the calculator, you're going to have 8,000, right? So it's going to be equals to 81, right? 83, 22, right? So you're going to have that, right? So now what I'm going to do is that I'm going to get rid of this thing, right? So since it's multiplying, I'm going to divide it. So it's going to be k plus 100 divided by 100, right, is equals to 8183, 22, and this is going to be divided by 6763. So now when you punch this into the calculator, right, you're going to get your value as being what? As being 1,209. So this is like 99, then it continues, right? Then now what we're going to do is that we're going to multiply this. We're going to get rid of this 100 in the denominator. So that's the same as k plus 100. Since it's dividing, meaning when it goes to the other side, it's going to multiply. So it's going to be 1,2099, right? And this is going to be multiplied by 100, right? So k plus 100 is going to give us 120, right, 99, and it's going to basically continue, right? Then now what we're going to do is that we're going to subtract. So k is going to be equals to what? It's going to be equals to 120, right, 999 minus 100, right? So meaning our answer is going to be that k is equals to what? This we're going to be left with 20,999. Remember the fact that this is percentage, right? So therefore k is equals to what? To 21%. So now we're going to do question 2. So question 2, it says a manager of a supermarket decides to do a survey of the number of items that customers order online and the time, right, that the packers take to have the orders ready for delivery. The supermarket receives 10 orders, right, on a certain day. The information for those orders are shown in the table. So this is the table that we have. The first question says draw a scatter plot in the grid provided in the answer. So I just have my own situation, my own grid paper, right? So with that is that we need to just draw. So I'm just going to draw the whole Cartesian, right? So we can have the whole graph, the whole scatter plot. So let me just do that. So we know the fact that, so it's going to be like this. Okay, before doing that, let me just go here, right? Is that we need to, this is the x-axis, right? So the x-axis, the minimum value is, let me start here. The minimum value is 3, right? So the minimum value is 3. Let's check. Yeah, the minimum value is 3. And the maximum value looking at it is 20, right? So meaning my range needs to start from, like, it needs to have 3 and 20, right? So I'm going to just divide my grid into basically 5, 10, 15, 20, right? So that's that. Then the other one is that for the y-axis, which is time, right, I see the fact that my minimum value here is 5, then my maximum is actually 12, right? So because if I want my scatter plot to be just more like on the y-axis to be a little bit longer, is that I'm going to use the intervals of 2, right? So that's what I'm going to do. So meaning I need in total, if I'm using the intervals of 2 in the y-axis, I need a total of 7 on the y-axis. Then if I'm using 5, right, I'm gonna basically divide them within like 5 periods, meaning I'm not gonna write 1, 2, 3. It's just that it's gonna be all 25, right? Let me just check how many blocks do I have on mine, right? If I'm gonna start here, I'll just do it. I'll check whether on the x-axis how I'm gonna divide it, right? So now we're gonna have the y-axis. So the y-axis, I said it's a total of 7, so it's gonna be 7. So it's gonna be, okay, cool. So it's going to be 7. So it's going to be from here. Let me just do this because I want to have the heading. So it's a total of 7, 2, 4, 6. And this is my 7. I'm going to stop at 8, right? So I have a total of 8. Then here is that, let me just check how many do I have. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, right? 15, 15, so it's 15, 16, 17, 17, 18, 19, 20. So I can just have an interval of basically 1 till 20, right? So it's going to be here till it's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? So that's what I have so far, right? So here we know the fact that my x-axis is the number of items, right? So my x-axis is going to be my number of items. So let's do that. So my x-axis is going to be the number of items, right? So it's going to be the number of items here. So here it's going to be the number of items. So let's say number of items, right? Then my y-axis is going to be time, right? So it's going to be time. So my number of items is x, then time is in minutes. So let me just put in minutes because it has a unit. So it's going to be in minutes, right? Then the title of my scatter plot, I'm just going to call it scatter plot. Okay, so it's going to be my title. So it's going to be this, right? So now having that is that let's put the values. We know the fact that here it's what? It's going to be 0 here. Then this is 2, 4. Then this is 6, 8, 10, 12, 14, 16, and this is 18. 2, 4, 6, 8, 10, 12, 14, 14, 16, 18, right? Then here is that I'm going to divide it by 5. So meaning this is 1, 2, 3, 4, then 5. We know it's going to be here. 6, 7, 8, 9. Then this is going to be my 10, 11, 12, 13, 14, sorry. So this is 10, 11, 12, 13, 14, 15. It's going to be here. 15, 16, 17, 18, 19, 20. So my 20 is going to be here, right? So that is that. Remember the fact that it ends till 20. So that's perfect, right? It ends till 20. So with that said is that now let's basically do our scatter plot, right? The first one is 10 is to 5, right? So we know the fact that x is 10. So 10 is here. Is to 5, so meaning 5 needs to be between 6 and 4, right? So that's that, right? The other one is 3 is to 5, so 3 is going to be 1, 2, 3, so 3 is here, right? Is to 5, so 5 is going to be again somewhere here between 6 and it's between 6 and 5, right? So we're done with that. The other one is 20 is to 9. So we know the fact that 20 is here. Then 9 needs to be between 10 and 8. So it's going to be somewhere here, right? Then the other one is going to be what? So the other one is 14 and so it's 14 and 7. So 14 is this one, right? 14 and 7. So 14, we know the fact that it's this one here. And 14 and 7. So we know the fact that 7 needs to be between here. So it's going to be here. So it's going to be between this two here. Right? So now we know the fact that this is done. Then 17 and 6. So 17 and 6. So 17 is going to be 15, 16, then 17 is here. Then 6 is this one. So this is going to be 6 is going to be this one. So it's going to be this. So it's going to be 2, 4, 6. So that's that. So this is sorted, right? Then now we're looking for 9 and 6. So 9 needs to be somewhere here, right? And 6 is somewhere here, right? So it's going to be here. Then this is going to be 6, right? So we have that. So this is going to be that. Then we have 12 and 8. So 12 and 8, we know the fact that 12 is going to be 10, 11, 12. So 12 is here. Then 8 is going to be this one. So it's going to be here. So it's going to be 2, 4, 6, 8. So it's going to be this one. Let me erase the small one. Yes, right? So that sorts out this one. Then we're looking for 18 and 11. So 18 is going to be where? It's going to be, if this is 20, this is 19, then this is 18. Then 11 is going to be between 10 and 12. So it's going to be somewhere here. So this here, somewhere here, right? So it's going to be somewhere there, right? So it's going to be 18. So it's going to be 2, 4, 6, 8, 8, 10, right? 11. So it's going to be somewhere here. So that is that. Then we have 15 and 10. So we have 15 and 10. So 15, we know the fact that it's here, and 10 is here, right? So it's going to be somewhere here. So that is sorted. Then we have 19 and 12. So 19 is the last one. It's the second last one. So 19 is the second last one. So it's going to be somewhere here. And 12 is going to be somewhere here. So it's going to be this point here, not here. So that is 12. Let me erase this, right? And that is going to be your scatter plot. So that's how you would do your scatter plot. So now 2.2 and 2.3, it says determine the equation of the least squared regression line, right? And 2.3 is write down the correlation coefficient, right, of the data. So both A and B, right, our boy 2.2 and 2.3 is that it needs your calculator. Already have a video, so I'll link it. But is that the final answer? I'm going to give you the final answer for two of them. But if you follow the video and also the steps that are provided here in the PDF, is that you're going to get it correct, right? So first is that for 2.2, right? So for 2.2 is that our A, right? So our A from the using the calculator is that you need to get that your A is going to be 3,079. And you're going to get that your B is equals to 0, so it's going to be 0,351, right? Then our formula, right, for the least square, it's going to be what? It's Y, right, is equals to what? It's equals to, is Y equals to A, right? It's going to be Y equals to A plus B X. Right? So that is the formula, right? So we know the fact that our A is going to be equals to what? Our A is going to be equals to 3,079, right? Then plus our B, which is going to be 0,351x. And that's how you find the least squared, right? So that's going to be your final answer. Then for 2.3, right? Also using your calculator, right? The least, the correlation coefficient is basically you solving for R, right? So in your calculator solving for R is that we find that our R in our question is equals to what? It's actually equals to 0,74. So that's your R, right? So that's how you find your R. So now moving to 2.4, it says the supermarket receives an online order for 13 items, right? And they say predict in minutes, right? Predict in minutes. In minutes, it will take a packer to take the order and have it ready for delivery, right? So what we're given is that this formula, do you see this linear regression, right? Let me just rewrite it again. So this linear regression is the one that you're going to use to predict, right? So we know the fact that our linear regression, our answer is what? It's going to be our Y, or our prediction. Yes, our linear regression, or at least linear regression is 3,008, right? Plus 0,35, right? X, right? So that's that. We know the fact that Y from our question represents what? Y represents in minutes, right? So it represents the minutes for packing. So this is the minutes for packing, right? So we know that, and we know that X represents what? Represents the number of, or the number of items. So it represents the number of items. So what are we given, right? They gave us the number of items. They told us the fact that X is equals to 13 items, and they want us to predict the number of, like, how long it's going to take, which is the minutes for packing. So we're looking for Y. So Y is equals to 3,08, right? Plus 0,35. Then the number of items, which is going to be 13. Punch that into the calculator. You find the fact that you're going to get 7,65, right? So the number of minutes it takes to pack 13 items, right, using the least regression is going to take 7,65 minutes to pack 13 items. Hope that makes sense, right? So that's how you would do this. So now we're going to do 2.5. It says explain why the y-intercept. So now going back to the formula, we need to basically determine what is the y-intercept, right? So our least regression is y is equals to 3,08 plus 3,35, right, x, right? So do you see the fact that this is a linear regression? This is a linear function, right? So if I had to rearrange it properly, this can be written properly as like this, which is going to be 0,35x plus 3,08, meaning this is your y-intercept, right? So this is your y-intercept. So they say the fact that explain why the y-intercept of the least squared regression in line, in line question 2.2 does not make sense in this context, right? So this does not make sense because to find the y-intercept, right, we need to let x equals 0. So what does it say? It says if I have 0 orders, so it means the fact that if I have 0 orders, right? So if I have 0 items to pack, right? So if I have 0 items to pack, right, it takes how many? 3,08 minutes to pack 0 items. That does not make sense, right? It's basically saying the fact that it takes 3 minutes, right, and a couple of seconds to pack 0 items. In this context, it does not make sense. So to answer this question, you can say the fact that it does not make sense. It does not make sense to pack 0 items in 3,0 minutes. So that's it. It doesn't make sense. So in this context, the y-intercept doesn't make sense. So that is what the question wants you to basically debug. Okay, so now we're going to do question 3. So it says in the diagram, triangle SRT. So what's triangle SIT? So it's SRT. So this triangle is drawn. And they tell us the fact that R lies on the x-intercept. So this is R. And they tell us that S, right, lies on the left of R. So as you can see it. And they tell us that T lies on the y-axis, right? And the coordinate of SRM is to 1, as you can see it here. Then they tell us the fact that the equation RT, so the equation for this line, right, is this, right? So the first thing that we're going to do before even answering the question, I'm going to write this equation, right, in terms of y, making y the subject. So we see the fact that the equation, we now have the fact that this is 2x, right? So it's 2x minus y, right, plus 10 is equals to what? Is equals to 0, right? So I'm just going to take everything to one side so that y can be the subject. So it's going to be negative y is equals to 2x, right? Sorry, it's going to be minus 2x, then it's going to be minus 10. So getting rid of the negative. So it's going to be negative y is equals to, pull out the negative, meaning everything that was negative is going to become positive. So this is going to be 2x plus 10. So therefore, if since both of them are negative, so this is the same as y is equals to 2x plus 10, right? So we wrote the line, the equation of this line. So let me just extend it, right? So this line here, right? Let me just do this. The equation for it is what? Is y. The equation for it is y is equals to 2x plus 10. Hope that makes sense, right? So now, just before even we answer question, if that's the case, this is a straight line. That means the fact that this point here, right? Do you see this point R here? This is what? This is going to be our x-intercept. And this point here is going to be what? This is going to be our y-intercept. And now let's deal with the y-intercept, right? So meaning this gives us the y-intercept. So meaning this is going to be 0 is 2 c. So our c is 10. So this is going to be like this. Then this one is r, which is going to be let x equals to, right? Let y equals to 0 to solve for it, right? So with that said, now let's answer the first question, which is 3.1, right? It says calculate the coordinate of what? Of r. We know the fact that r is the x-intercept, right? So meaning we need to let y equals to 0, right? So we know the fact that our equation is this one. So we know that our equation is y is equals to 2x, right? Plus 10. So it's going to be plus 10. So we let y equals to 0. So 0 is equals to 2x plus 10. So therefore, take the 10 to the other side, or yeah, take the 10 to the other side. So this is going to be negative 10 is equals to 2x. Divide both sides by 2. So it's going to be negative 10 divided by 1 divided by 2 is equals to x. So therefore, x is going to be equals to negative 5. Right? So the coordinate of r in our case is going to be negative 5. Since we let y equals to 0, so it's going to be negative 5 is to 0. Right? So this equation here, this coordinate here is going to be negative 5 is to 0. Hope that makes sense. Okay, so now we're going to do 3.2. It says calculate the length of RT and leave your answer into set form. So we need the coordinate of R and T. So we already know that the coordinate for R, right? We already solved it, which is going to be negative 5 is to 0. Then we know the coordinate of T. Remember when going up, I said the vector is the what? The y-intercept, which is 0 is to 10. So we know the fact that T is what? Is 0 is to 10, right? So we're looking for the length. So we know the fact that we're looking for RT, which is we're using the distance formula. So the distance formula, this is going to be the square root of what? Of XR, right? Minus X what? XT all squared plus this is going to be YR, right? Minus YT all squared, right? So then this is going to be the distance formula. One key importance, right, is that when you solving for the distance formula, if you're going to start with XR, you need to make sure the fact that the next one you start with YR. So if let's say I started with XT, meaning here needed to be XT. Hope that makes sense. You need to keep the consistency. Whoever that you start with, right, needs to be the one that follows for your Y. Hope that makes sense, right? Hope that makes sense. So now let's substitute, right? So when substituting, we have the fact that RT is equals to the square root. This is going to be what? XR is negative 5, and this is going to be minus what? Minus 0, right? And this is going to be all squared plus, this is going to be what? This is going to be 0, right? Then this is going to be minus what? Minus 10, and this is going to be all squared, right? Then you punch that into the calculator. So when you punch that into the calculator, you're going to get your answer as being what? It's going to be the square root of 125. 125 units. So this is your answer for this question. So question 3.3, it says it is also given that 2RT squared is equals to 5 SR squared. Then we need to calculate for M, right?
So let's go back and see where m is, right? So we see the fact that our m is here, right? So what are we given? We're given the fact that RT, right? So we're given the fact that 2RT, right, is equals to twice that. So we need to find, so what do you call this? What do we need to do? We need to find what is RT, right, and what is SR. Then from there is that having that is that we're going to be able to basically solve for this given our information. So let me just do it, right? So we know the fact that we're given the following. We're given the fact that R2RT squared is equals to 5SR squared, right? So now we already know the fact that RT, right, is equals to what? To the square root of 125. We already know that, right? So we need to find SR, right? So to find SR is that we need 2 points, right? We need the coordinate of S, and we see that the coordinate of S is what? Is M is to negative, is M is to 1. So we know the fact that the coordinate is M is to 1, right? So it's M is to 1, and we need R, right? So let's go back. We know that R is what? Is negative 5 is to 0, right? So now we're going to use the distance formula, but making sure that we know the fact that our answer is going to be in terms of A. Hope that makes sense, right? So now using the distance formula, we know the fact that this is going to be equals to what? To the square root of what? Of x is, right? Minus what? XR all squared plus this is going to be y is minus yr all squared, right? So we know this, right? So now we know the fact that SR is going to be what? Let's substitute. We know the fact that XX is, or what you call this, X is going to be M, right? And this is going to be minus negative 5. So it's going to be negative 5. Put inside in a bracket because of this negative is going to affect it. And this is going to be all squared plus this is going to be YS, which is going to be 1. Then this is going to be minus 0, right? And this is going to be all squared. So now we're going to have that, right? So now we know the following. We know the fact that SR, so yeah, let me just write it here. We know the fact that SR is going to be equals to the square root. Let's clean this up. This is the same as M plus 5 all squared, right? And this is going to be plus 1 squared, right? So this is going to be like this. Therefore, we know the fact that SR is equals to the square root of what? The square root of m plus 5 all squared plus 1, right? So we know the fact that this is our SR. So now taking what we given, which is this, right, we're going to substitute our RT and our SR, right? So we know the following. So we know the fact that we have what? We are given the fact that this is 2RT squared is equals to what? Is equals to 5, right? R squared. Let's substitute, right? So we know the fact that 2, what is our RT? RT is square root of 125, right? All squared is equals to 5. Then we know the fact that SR, we calculated it as being this one. So now it's going to be what? It's going to be the square root, right? Of what? Of M plus 5, right? All squared plus 1, and this is all squared, right? So what's going to happen is that the square and the square root are going to cancel each other. So you're going to have 2, and this is 125, right? Because we got rid of the square root. And here's going to be 5. Then the square root is going to be, we're going to get rid of it. So it's going to be m plus 5. So let me just do this. So I'm just going to put a square bracket because there's another bracket. So it's going to be m plus 5 all squared plus 1 then square bracket, right? So this is going to be square bracket. So that's that, right? What we do now is that we're gonna basically divide both sides by 5 so I can get rid of this 5. So it's going to be what? It's going to be 2 multiplied by 125 is going to be 250, right? Divided by 5. And the side where we're going to be left is going to be m plus 5 all squared plus 1, right? So when you say 250, right? When you say 250 divided by what? 250 divided by 5, you're going to get your answer as being what? As being 50. So this side is going to be 50 is equals to what? To m plus 5 all squared plus 1. So what I'm going to do now is that I'm going to expand the m plus 5 to the power 2, right? So it's going to be 50, right? Is equals to m squared, right? plus 10m plus 25, then this is going to be plus 1, right? So what I'm going to do is that I'm going to take the 50 to the other side. So when I take the 50 to the other side, so I can expand this is going to be 0 is equals to m squared plus 10m, right, plus 25, right, plus 1, then this is going to be minus 50, right? So now what we're going to have is the following, is that 0 is going to be equals to, when you say 25 plus 1 is going to give you 26, minus 50 is going to give you what? It's going to give you negative 24. So this is going to be m squared plus 10m, right, minus 24, right? Then you're going to factorize this. So when you factorize this, you're going to have 0 is equals to what? Into two brackets. So it's going to be m minus 2, then this is going to be m plus 12, right? And now we're going to equate this bracket by 0, so it's going to be m minus 2 is equals to 0, or it's going to be m plus 12 is equals to 0, right? So m is going to be equals to what? Positive 2, or m is going to be equals to negative 12, right? So remember the fact that we have two m's, right, and we're solving for m. And if we go up, right, we see the fact that m is on the negative side. So our answer cannot be m is equals to positive 2. So therefore, our m is equals to 12. And this is your final answer. So now 3.4, it says, it is further given that b lies, right, on, so we see the fact that they tell us that v, which is this point, right, lies on the line st, as you can see it, right, such that vr, so this line, right, so such that this line, right, vr, this line, right, is perpendicular to this line, so this line, right? So we know the fact that they tell us the fact that these two are perpendicular, which creates a 90 degrees, right? So with that, they said the fact that ST, right, determine the equation of BR. So the equation that we're looking for is this one, right? We're looking for the equation of that line, right, in terms of y is equals to mx plus c, right? So now what do we see? We see the fact that when finding the equation, right, we need the following. We need it in this form, right? So we need it in y is equals to mx plus c, right? So we need the gradient and we need c, right? So to find the gradient is that you need two sets of coordinates, right? So we know the fact that we're looking for the equation of this line, right? But we see the fact that we only have one set of coordinates, right, which is not going to work well. But we know the relationship between these two, right? The fact that this line and this line are perpendicular to each other. So I can use the gradient of this line, right, to find the gradient of this one, right? And this is the relationship that we're going to use. Since, so I'm going to just write it here. So you know the fact that since, right, since we know the fact that ST, right, is perpendicular to VR, right? Since we know the fact that we know that now the gradient of ST multiplied by the gradient of VR is equals to negative 1. So we're going to use that relationship, and maybe let me just put this inside a box, right? So we're going to use that relationship, the fact that since we know that that is the case, therefore we can find the gradient of what? We can find the gradient of ST since we have both coordinates, right? Then use this relationship, right, to basically find the gradient of VR. Hope that makes sense, right? So that's what we're going to do, right? So we're gonna first find the gradient of ST, what you call this, of MC, right? So we know the fact that the gradient of ST is equals to YS minus YT divided by XS minus XT, right? So we know that the 2 points, so I'm gonna write the 2 points here. So we know the fact that S is what? Is negative 12 and 1, so it's gonna be negative 12 and 1. And we know the fact that T is what? Is 10 is to what? Is 0 is to 10, right? So with that said, now we're going to basically what? We're going to basically substitute the rest, right? So we're going to substitute the rest. So we know the fact that the gradient of ST is equals to YS. We know the fact that it's going to be 1, right? Minus YT is going to be 10, right? And this is going to be divided by what? By XS, which is going to be negative 12, then it's going to be minus 0, right? So when we punch that into the calculator, right, when we punch that into the calculator, we're going to find that the gradient is going to be what? So we know the fact that the gradient of ST, when we punch that into the calculator, is going to be equals to 3 over 4. Hope that makes sense, right? So we know the fact that it's going to be 3 over 4. So now going back is that we know that the relationship that the gradient of ST, right, multiplied by the gradient of what? The gradient of VR, right, is equals to -1. We already have the gradient of ST, which is going to be 3 divided by 4 multiplied by the gradient of VR. So since this is multiplying, when we take it to the other side, it's going to be what? Division. So it's going to be the gradient of VR is equals to -1. So this is going to be -1. -1 divided by 3 over 4. Punch this into your calculator. You know that your gradient of VR is going to be equals to what? It's going to be equals to -4 over 3, right? Which is the gradient that we want for VR. So hope that makes sense. So now we know the fact that our equation is going to be y is equals to, right, the gradient of what you call this, the gradient of VR, which is going to be -4 divided by 3, and this is going to be x plus c. So now we need to solve c, right? So to find c is that on the line that we're finding the equation, which is this one, right, is that we need to take any set of coordinate. We can't take v because of v is not there. So we're going to take this coordinate, right? Substitute this coordinate, which is r, to find c, right? So we're going to do what? We're going to say substitute r, which is -5, is to 0 to find c. So let's do that, right? So y, right, is equals to, so let me just substitute it because we have it. So it's going to be what? It's going to be 0 is equals to -4 divided by 3, and this is going to be -5 plus c, right? So now punch this into the calculator. So punch this into the calculator. So when you punch that into the calculator, you're going to get the fact that 0 is equals to what? Is equals to positive. So it's going to be 20 divided by 3, right? So now, sorry, plus c. Take this to the other side. So it's going to be -20 divided by 3 is equals to c. So therefore, we know that c is equals to -20 divided by 3, right? So now the complete, what they complete, so the equation for line VR is what? It's going to be y is equals to, then it's going to be -4 over 3, right, x minus 20 divided by 3. And this is going to be the complete answer for this question. So now we're going to do 3.5. It says, hence show the coordinate of v is -8 is to 4, right? So what do we have? How can we find that, right? We see the following. We see the fact that, you see the fact that this line, right, and I'm going to just extend it, right? So if we take this line, right, this line here, which is, we already found the equation for it, right? If we take the line of this equation of this one, and also if we also take, okay, cool. So if we also take this line here, all right, do you see the fact that these two lines intersect at V, right? Do you see the fact that both those two lines intersect at V, right? So what is the nice thing? We already have the equation line of this one. So the equation of VR, we have it, right? We solved it in the previous question, which is going to be -4 divided by 3x, right, minus what? Minus 20. So this is going to be minus 20 divided by what? Divided by 3. We already have this, right? So we have that line. So we need the line of SR, right? And we can find the line of XR because we already have what? We already have the gradient of this line, which is perfect. So we need to find C and find the line of that one, right? If we equate both this line, is that we can find the coordinate of V. So let's do that, right? So now we have the following. We know the fact that we already given the fact that, so we finding V. So let's say V is the intersection of line what? Line VR and line S. So line ST. So line ST. So what are we looking for? We're looking to equate the line VR with the line ST. We already have the line VR, right? We already have the line VR, which is going to be negative 4 over 3x minus 20 divided by 3, right? So now what we're looking for the line ST. And we know the fact that the line ST, we already have the gradient of ST. If we go up, right, we already know that the gradient of ST is this one, which is 3 over 4, right? So we have the line, the gradient for that. So it's going to be 3 over 4 x, right? And this is going to be plus c. So we're going to substitute what? We're going to substitute, you can pick either or which one to substitute between the two, right? To find c. So I'm going to substitute t in my case. So I'm going to substitute t, which is 0 is to 10, to solve for c. So let's do that. So it's going to be what? It's going to be 10 is equals to 3 over 4, and this is going to be 0, right? And this is going to be c, right? So therefore we see the fact that c is equals to 10. So let's substitute y as t is equals to 3 over 4 x plus 10. All right, so we already have that, right? So remember the fact that the goal is to find what? The goal is to find this one. And maybe let me just put this. The goal is to find this intersection, right? So now we have both the equation of SRAVR, right, and the equation of ST, right? So now with that said is that let's equate them together. So we know the fact that the equation of VR, so the equation of VR is equals to the equation of ST, right? So VR is what? Is negative. Remember, let's go up. It's going to be what? It's negative 4 over 3. So it's going to be negative 4 over 3 x, right? Plus what? Sorry, minus 20 over 3 is equals to ST, which is going to be 3 over 4, right? X plus 10, right? So what we're going to do is that we're going to take everything that is in terms of x in one side and everything that is in terms of what? That is in terms of numbers in one side. So it's going to be negative 4 over 3x, right? And this is going to be minus 3 over 4. X is equals to what? Is equals to 10. And this is going to be plus 20 divided by 3, right? So then punch this into your calculator. So when you punch that into your calculator, you're going to get the fact that here it's going to be negative 25 over what? Over 12, right? X. And this side is going to be what? It's going to be, and this side is going to give you 50 divided by 3, right? So now what we're going to do is that we can cross multiply. So this negative 25, this x is in the numerator. So this is the same as having 25 x divided by 12, and this is the same as having 50 divided by 3. So cross multiply, we're going to have negative 25 x multiplied by 3 is equals to 50 multiplied by 12. When you punch this one into your calculator, right, when you say negative 25 multiplied by 3, you're going to get your answer as being what? When you say 25 multiplied by 3, right? So you're going to get your answer as being negative 75 x, and on the other side when you say what, when you say 50 multiplied by 12, you get your answer as being 600, right? Divide both sides by 75, so it's going to be x is equals to 600 divided by negative 75. Then you find that your x is going to be equals to negative 8, which is perfect. If you go up, remember the fact that they say we need to prove the fact that our v coordinate is negative 8 and 4. So we already have the x coordinate, right? So now to find the y coordinate is, remember the fact that you found the intersection between the two equations, right? Which is v, r, and st. So you can pick either or, right? And substitute your negative 8 to find your y coordinate, right? So what I'm going to do is that I'm going to substitute, right? So I'm going to substitute x equals to negative 8 into what? Into, let me just pick either or equation. So this one I'm going to pick into y as t. So we know that y as t is equals to, let me go back, it's going to be 3 over 4, right? 3 over 4 x plus 10, right? It's going to be plus 10. So we know the fact that y is equals to, so it's going to be 3 over 4, right? And this is going to be what? Negative 8 plus 10. We punch that into the calculator. We get that our y is going to be equals to what? Our y is going to be equals to positive 4, right? Which matches exactly with what? With what the question wants. So therefore, we know that our v coordinate is what? Is negative 8 is to 4. So that's how you would solve this question. So now we're going to do 3.6. It says if r prime is a reflection on r about the line y, what you call this, about the line x is equals to 0. What is the line x equals to 0? We know the fact that this point here is 0, 0, right? So if let's say, and I'm going to just give a general so that you can see why I conclude to what I'm concluding, right? So if we were given the following, if let's say the fact that it reflects on the line, maybe let me do it in red, y is equals to 2, right? Sorry, the line x is equals to 2, right? Is that you are going to go here and find your 2, right? And that line will be the line that is cutting through it like this, right? Because this is going to be x, this is going to be x is equals to 2. So with that, taking that into mind, right? X is equals to 0. The line is here because this is 0, 0. Meaning the line x is equals to 0 is the same as reflecting on the y-axis. The y-axis. Do you get that? So the line that is going to be reflecting is going to be this line. Sorry, it's going to be this line, right? So it's going to be that line. So I just wanted to show you the fact that why I'm saying the fact that reflecting, right, reflecting on this line is the same as reflecting on the y-axis. Hope that makes sense. Because of that, it's the same line. Hope that makes sense, right? So with that said, is that we know the fact that if it's reflecting on this line, is that meaning this point here, right, needs to be on the other side, right? Meaning R is going to be here. Then what is changing? The what you call this, what's changing? So if we remember the fact that if we're talking about reflecting, so let me just do here, maybe I should do a couple of notes, right? So we have established that x equals to 0 is the same as, right, y-axis, right? So now understanding what is reflecting on the y-axis, right? It means that what? It means that your x coordinate becomes negative. So it means that your x coordinate changes its sign. So this is how it is. So if you have f of x, right, right, and we say the fact that f of x goes into the reflection, right? When it goes to a reflection, meaning now we name it something else, meaning g of x, and the g of x, if it's reflecting on the y-axis, that means the fact that what? The x coordinate becomes negative. So this is going to be f negative x. Hope that makes sense, right? So since this is negative, our r prime here is going to be what? It's going to be positive. So it's going to be 0 is to 5. Hope that makes sense. Because of this is where the whole idea comes from. Hope what I'm saying makes sense, right? Why we concluded the fact that this point here is going to be what? It's going to be a positive 5 because of when you're reflecting on the y-axis, it affects x, right? Meaning if x was negative, it becomes positive, and if it was positive, it becomes negative. Hope that makes sense. So that is the idea, right? So with that said, is that now we know the fact that what is y prime. So what they want us to now find, we need to find the area of what? Of R. So let me do this. So the area of R, right? So it's going to be from R. So let me just write it. Yes. So let me just block it out. So it's going to be from R, right? So it's going to be RV, right? RV. Then this is going to be RT. So from here, right? RT. Then it's going to be TR prime, right? Then it's going to be back to R and R prime. So this area, right? So the one that is blacked out, that is the area that we're looking for. The nice thing is that remember in the previous question is that they already told us the fact that this is 90 degrees, right? And also here, do you see the fact that these two are both also 90 degrees, right? So they both 90 degrees because of this is from what? This is the y-axis intersecting with the x-axis. So this is the y-axis intersecting with the x-axis. So these two are also 90 degrees. So what is nice? So the area of this whole thing is this 390 degrees added together, right? So now this area, I'm going to do what? I'm just going to block it out, the three triangles. So I'm going to do them again. So I'm going to say it's this one. So it's going to be this, right? This triangle, right? The blue triangle, right? Plus this triangle. Okay, cool. So let me just do this. Let me just do this. Yes. Okay. Okay. So this triangle. So let me just do this, right? So knowing the fact that the three, right? So I'm just gonna add this one. So we know the fact that it's the whole thing because I just want to divide them, right? So let's say it's this triangle. So it's gonna be this triangle, the green one, right? Right? Then plus this triangle, the blue one, and lastly this triangle, which is going to be the purple one, right? So that is the three triangle that we're going to be finding. So we know now that the area, so let me go back to black. So the area of r v t r prime is equals to what? Is equals to the area of triangle. So the purple one, which is going to be t v r, right? Plus the area of triangle, the blue one, which is going to be TRO. Then lastly, it's going to be plus the area of the triangle, what? Triangle TOR prime, right? So what I'm going to do is that I'm going to match it up with highlighting. We know the fact that this is the purple one, right? And this is the blue one. And lastly, this is the green one, right? So now we're going to need to find the area of individuals, right? So now we know the fact that the area of the purple one, right? So we know that the area of the purple one of triangle TVR is equals to half base times height, right? So what is the base? So just looking at the purple one, right? The base is going to be VR, right? So the base is going to be, this is the same as half. Base is going to be VR. Then the height is going to be this one, right? So the height is going to be this one. So the height is VT. So the height is going to be VT, right? So from here, we need to find what? We need to find the distance between VR and VT. So let's do that, right? So we're going to find the distance of VR and VT. So, so we're going to find the distance of VR and VT. So it's going to be VR. So we're going to say VR here is equals to what? Is equals to the square root, right? And we know the fact that V is what? Going back, we know the fact that V, let me just put in, remember it was like negative 8 and 4. Let me just confirm, yes. And yeah, we have everything. So we know that V is negative 8 and 4. And we know the fact that T is what? Is 0 is to 10. And lastly, we know the fact that R is what? R is negative 5 is to 0, right? So we're looking for VR. So VR is the same as having what? Having X. So it's the same as having XV minus XR all squared plus what? Plus YV minus YR all squared, right? So this inside the square root. So VR, let me just zoom it in, right? So VR is equals to, let's substitute what you call this, XV is negative 8, right? Minus what? Minus this one, which is going to be negative 5 all squared, right? So it's going to be this minus this, right? Yes, that makes sense. Then this is going to be what? This is going to be plus, this is going to be 4, right? Minus, this is going to be 0, and this is going to be all squared. Then when you punch that into the calculator, you see the fact that VR is equals to what? Is equals to 5, right? So we have that. So now we're looking for what? We're looking for VT, right? So we're looking for VT. And we know the fact that Vt is going to be what? It's going to be xv minus xt, right? All squared plus this is going to be yv minus yt all squared, right? So that, right? So therefore Vt is going to be equals to what? It's going to be equals to the square root. What is which you call as xv is going to be negative 8 minus Vt, so it's going to be 0, and this is going to be all squared. This is going to be plus v, which causes yv is going to be 4 minus what? Minus 10, and this is going to be all squared. So punch that into the calculator, right? So when you punch this into the calculator, when you see that vt is equals to what? It's actually equals to 10, right? So now you know the fact that that is that. So now I can find the area of this, right? So finding the area of that, so I'm just gonna duplicate it, right? Put it here. So I know the fact that now this is going to be the same as what? 1 over 2. And this is going to be VR is 5. And this is going to be 10, right? So punch that into the calculator. You're going to get it as 25. Hope that makes sense, right? So now we're going to move to what? We're going to move to finding. So this was the area of the purple one, right? Let's color coordinate it, right? Now looking for the area of what? Looking for the area of the next one, which is going to be the area of triangle. Let's go up. The blue one, which is TRO, right? It's equals to half base times height. So now we're going to go to the blue triangle, right? What is our base? Our base is RO. So our base is RO, right? So we see that our base is RO. So it's going to be a half RO. Then our height, right? Our height is what? Our height is here, which is TO. So our height is TO, right? So if we go back, right, we see the fact that the distance between here and here is just the, what you call this, the x coordinate. So this is going to be 5, right? So the distance from here to here, this is going to be 5. And the distance from here to here is the y coordinate. So this is going to be 10, right? So we know that, right? And also just to fill in for the green one, it's the same thing. The distance from here to here is this one, so it's also going to be 5. The reason why I didn't write -5 here is because of distance is always positive. Hope that makes sense, right? So now, with that said, we know the fact that now the base is going to be what? It's going to be 5, right? So the base is going to be 5, and the height is also 10. So now this is also 25, right? So that is going to be the area for that. So let me just move it closer to here. Yeah, so let me move it closer to here. And this is the area of the blue one, right? So this is the blue one. So now let's find the area of the last one. Area of triangle, which is the triangle is the green one of TOR prime. So it's going to be TOR prime, right? And this is going to be equals to half base times height, right? So let me just move this because it's just further away, right? So this is the same as equals to half. Let's go back to the green one. What is the base? The base is going to be RO, OR prime. So this is going to be OR prime, right? And the height is going to be what? The height is going to be TO. So it's going to be TO, right? So this is the same as what? A half. OR prime is 5. And TO, we already know that it's 10. So this is also equals to 25, right? And this is the area of the green one. So this is going to be the area of the green one, right? So now finalizing it, I'm just going to take this and copy it. So duplicate it, cut, and it's going to come here, right? So we know the fact that the area of the purple one, the area of the purple one is 25. Also the green one is 25. Also the blue one is 25. So this is going to be equals to 75 units squared. So that's how you would answer this question.
Okay, now let's do question 4. It says in the diagram, M is the center. So we see the fact that M, which is here, is the center, right? And they tell us the fact that the center of the circle having this equation. So we see the fact that it has this equation, right? And since the equation is complete, that means the fact that we can find completely what's the coordinate at the center. So the x coordinate comes from here, right? So since it's negative here, meaning the x coordinate when you take it outside is going to be positive, so it's going to be 3. Then here, since it does not have any y coordinate, meaning it's just y squared, meaning this is going to be 0, right? So the coordinate for M is this, which is going to be what? It's going to be 3 is to 0, right? Then they tell us the fact that and the radius, meaning the distance from here to here. So let me just show you. From the distance from here to here is going to be 5 because of this is 25. So this is r squared. So this 25. So r squared is equals to 25. Right? So it's equals to 25. So therefore, r is going to be equals to 5. So this distance here, from here to here, is what? It's 5, and here to here it's 5. So let's write that. Right? We know the fact that this distance here is going to be 5, and also from M to T is also 5. Hope that makes sense, right? Then they tell us the fact that E is negative 1 is to 3, as you can see it, and T are the points on the circle. So we see the fact that E and T are the points that lies on the circle, which are on the circumference, right? Then they continue and tell us the fact that EC, right? So EC, this line here, right, is the tangent to the circle at E. So since this is a tangent and this is a radius, because of it's a point going from the center till the circumference, is that means the fact that this angle here is 90 degrees, and the reason for that is 10 chord, right? Then it tells us the fact that at E and cuts the x-axis. So do you see the fact that that line here, right, cuts the x-axis at D, right? So meaning that line cuts here and D, right? And they tell us the fact that ET, right, so is ET. So ET, so this line, so is E. So this line here, ET, is 15/4 units. So we see the fact that this portion here, and I'm just gonna emphasize it with another color. So this portion here, right, they tell us the fact that it's what? That portion there is equals to 15/4 units, right? Units, and they tell us the fact that MT is produced to meet. So MT, so let's go and find MT. So this is M and this is T, produces so that it meets what? So it produces so that it meets the tangent at C. And they give us that the coordinate of C is -7 and P. So we don't have P. So now answering the first question, right? They say, what is the size of CEM? So let's find what CEM, right? So let me just do that. So I'm just going to do it in green, right, to find CEM. So we see the fact that C, it's here. E, it's here, right? So it's going to be CEM. So it's here, right? So they're asking about this angle. This is the angle that they're asking. what is that value, right? So that value already from when I was discussing is equals to 90 degrees, right? So CEM is equals to 90 degrees. You can write your reason. I love writing the reason. So, and even if you don't write the reason, they're not going to penalize you. They just want the angle. The reason why is that it's tangent perpendicular to radius. So that is the reason why it's 90 degrees. So now doing 4.2, it says determine the equation of the tangent EC. So what are we determining? We're determining the equations of this line. So I'm just going to emphasize it with, yes, with the color, right? So I'm going to emphasize it with red. So we're looking for the equation of this line, right? So this is the line that we want, that equation of the line, right? So we know the fact that the equation of the line needs a couple of things. We know the fact that the equation of a line is y is equals to mx plus c, right? So we need the gradient, then we need c, right? So finding the gradient. So we need 2 points, complete points, right? We see the fact that the 2 points is it's C and it's E. Only E is complete, but C is not complete, right? So we can't find that, right? And remember the fact that from the previous, I already added this is 3 is to 0. Remember the fact that when we were doing the question, this is 3 to 0. So we already know the fact that this is also 90 degrees. So we're going to use the relationship between these two, right? These two lines to basically find the gradient. Because of this, it's a complete coordinate. We have 2 complete coordinates. So I'm going to use finding the relationship of perpendicular to basically find this one. Hope that makes sense. So what I'm going to do is that we know the following. We know that the gradient, right? So we know that the gradient of EM, right, multiplied by the gradient of the one that we want, which is EC, is equals to -1, right? Because what? The reason is because of EM is perpendicular to what? To EC, right? Because we proved it in the previous question, right? So with that is that we know the fact that we can find the gradient of what? Of this one, because we have 2 complete coordinates. So that's what we're going to do, right? So we're going to find the gradient of EM, right? So EM, right, which is going to be equals to the gradient of, so it's going to be YM divided by XE minus XM. So what I'm going to do is that here I'm going to put the coordinate of M, which we know the fact that it is 3 is to 0, and the coordinate of E, which we are given as -1 and 3. So it's going to be -1 and 3, right? So we're going to find the gradient right now. So finding the gradient is that we're going to substitute. So let's substitute. So it's going to be like E, so it's going to be -1, right? Minus what? Sorry. I substitute. Oh, let me go back. This is too big. So we know the fact that YE is 3, so it's going to be 3, right? Minus 0 divided by what? By -1 minus 3, right? So we know that. So now we know the fact that when we punch this into the calculator, we're going to get the gradient of EM as being equals to what? As being equals to -3/4, right? But then remember the fact that the gradient that we want is of this one. That's the gradient that we want, right? So we know the following. So we know the fact that from the relationship, so let me gonna take it again, right? So I'm gonna just duplicate it and cut it. And I'm just gonna put it here. Right? We already know the fact that EM is -3/4 multiplied by the one that we want, the gradient of EC is equals to -1. So we're going to take the -3/4 to the other side. So since it's multiplying, when it goes to the other side, it's going to divide. So it's going to be the gradient of EC is equals to -1 divided by -3/4, right? So therefore, when you punch that into your calculator, you're going to get that the gradient of EC is equals to what? Is equals to 4/3, right? So that's what we have. So now we have the gradient of the line that we want, which is this one, which is great, right? So now we're going to update the equation. So we know the fact that this is going to be what now? This is going to be y is equals to 4 over 3 x plus c. So now we need to solve for c. So how do we solve for c? Is that on that line, we need to substitute a complete coordinate, so which is e, to solve for c. So that's what we're going to do, right? So I'm going to substitute what? I'm going to substitute e, right? Which is going to be what? Remember that our e is negative 1 is to 3. Negative 1 is to 3 into y, right? To solve for c, to solve for c. So let's do that, right? So we know the fact that now it's going to be 3 is equals to 4 over 3. Then this is going to be negative 1 plus c, right? So this is the same as 3 is equals to negative 4 over 3, right? Plus c. Take the negative 4 over 3 to the other side. So it's the same as what? This is going to be the same as 3 plus 4 over 3, right? Is equals to c. So when you punch that into the calculator, right? When you can punch that into the calculator, you're going to get that your c is equals to what? Is equals to, c is going to be equals to 13 over 3, right? So therefore, the equation, right? The equation of the tangent is what? Is as follows, is that y is equals to what? Is equals to 4 over 3x plus what? Plus 13 over 3. And that's how you would do number 2. Okay, now let's do question 4.3, right? So with 4.3, it says calculate the length of DM. So this is DM. So this is DM. And we see the fact that the point D, right? This point D lies where? Lies on the tangent line. So it lies on the tangent line, which is this one, right? But the nice thing is that on the previous question, we already found what? We already found that equation of the tangent line, right? We already know the fact that this is y is equals to 4 over 3 x plus 13 divided by 3, right? And we see the fact that d is what? D is the x-intercept on that line, right? So meaning we can find d. So we know the fact that, let me say, d is the x-intercept on the tangent line. So meaning we can find the coordinate of d, then we can find the distance, right? So let's find d, right? So finding d, we know the fact that we need to say what? We need to say, I'm going to say x-intercept, right? Meaning let y equals to 0, right? So with that is that we have the equation. So our equation is this one. So let me just rewrite it again. So it's y is equals to what? Y is equals to, let me just do it like this. I need order, right? So on this line, so this line, we know the fact that it's y is equals to what? Is equals to 4 over. So it's going to be 4 over 3 x, right? Plus 13 over 3, right? So we know the fact that this is going to be 0 is equals to 4 over 3 x plus 13 over 3. So we're solving for x, right? So take the 13 over 3 to the other side. So it's going to be negative 13 over 3 is equals to 4 over 3 x, right? So now divide both side by 4 over 3. So this is the same as negative 13 over 3. Since it's multiplying, so it's going to be divided by 4 over 3, right? Is equals to x. So punch this into the calculator. When you punch that into the calculator, you're going to find that your x is what? Your x is going to be equals to, so your x is going to be equals to negative 13 over 4, right? So now we know that the coordinate of D is what? Is negative 13 over 4. So this point here is going to be negative 13 over, so it's going to be negative 13 over 4 is to 0. So that's that point, right? So remember the fact that we're looking for DM. right? So dm is going to be the square root of what? Of xt, right? Minus xm all squared plus yd minus ym all squared, right? So that is that. So we already know the fact that d, right, is what is negative 13 over 4, right, is to 0. And we know the fact that m is 3 is to 0, right? So we know that that 2 is that, right? So now with that said, right, we need to find what? We need to find the distance. So finding the distance is going to be what? We're going to substitute. So dm is going to be equals to the square root of xt. So it's going to be negative 13 over 4 minus what? Minus 3 all squared plus this is going to be 0 minus 0 all squared, right? So when you punch that into the calculator, you see that dm is equals to what? Is equals to 25 divided by what? Divided by 4 units. So that's how you would find this distance dm. Then 4.4 says show that p is equals to 5. So where is p? We see the fact that p is here, right? P is here, right? And what is the nice thing? We already know the fact that this equation of the straight line, which p is also on that line, is this equation. So the nice thing is that if we substitute c here, is that we can solve for p, right? So that's what we're going to do. So we're going to basically use what? Use the equation of the tangent. So using y is equals to what? Y is equals to 4 over 3, right? X plus 13 over 3, right? So what we're going to do is that we're going to substitute the coordinate c, which is the coordinate c is what? Is that we're going to substitute, which is negative 7 is to p to solve for p, right? To solve for p. So that's what we're going to do. So when we substitute, we're going to have what? We're going to see the fact that p is equals to 4 over 3. Then this is going to be negative 7 plus 13 over 3. Therefore, p is equals to, when you punch that into the calculator, you're going to see that p is equals to what? Is equals to negative 5. So that's how you show the fact that that is equals to negative 5. Hope that makes sense. So now we're going to do 4.5. It says calculate the coordinate of S if SEMC is a parallelogram and the coordinate of S, right, is less than 0. Meaning that the x coordinate, this, right, let me zoom it in. This means the following. It means the fact that the x coordinate, so the x coordinate of S is negative. Ooh, okay, I spelled negative wrong. Is negative. Meaning, in conclusion, the fact that it should lie from here, this side, it should exist here and not exist this side. Hope that makes sense, right? So now let's draw the parallelogram, right? So we see the fact that it's going to be what? It needs to lie somewhere where? It needs to lie somewhere here, right? And how do we see that? We see the fact that I'm just gonna connect first the points that we see, right? We do not have S. So we know the fact that it's gonna be E. So it's gonna be EM. So there's 2. Right, so let me just do this. It's EM, right? And also there's 2. So it's from here to here, right? Then meaning for us to have a complete parallelogram, it needs to be somewhere here, right? So our S needs to be somewhere here. So meaning it's going to be here, which satisfies this condition. Do you see that? It satisfies this condition because of it's in the negative x-axis. Hope that makes sense. So connect it here. So that's our parallelogram. So our S is here, right? So we're looking for this point. We're looking for this point, right? We're looking for that point, right? So for us to find that point is that what do we have? We need to look at the properties of a parallelogram, right? And from there is that the property that I see that it's going to work for me to get this point is this following property. So let me just write it down. It's a property of what? Of diagonals, right? So I'm just going to say properties of a parallelogram. So I'm going to say properties, right? So I'm going to say property Properties of parallelogram. Right, is that the property that I'm going to look at is what? The diagonals, which says the fact that the diagonals, right? So the diagonals bisect each other. I'm about to explain what it means, bisects each other. And I'm going to show you on how this property is going to help us, right? So we know the fact that the diagonals bisect. Okay, cool, wait. Bisect each other. Let me just sort this out. Okay, cool. Let me highlight this. All right. So we know the fact that the diagonals bisect each other, right? So I'm just going to look at the one that exists already, because we already calculated that this is what? This point here is -5. So we already know the fact that this point here is -7, -5. We already calculated it from the previous one, right? So what it says is that, do you see the fact that this whole line here, right? Is that this whole line here, let me find red. This line is a diagonal, right? Going from where? Going from E to C. This point, like this line there, right? It's a what? It's going to be, I just want it in red. So this line here is a diagonal, right? That is a diagonal, right? So it says if we have diagonals bisect each other, it's the meaning we need to have a diagonal from S to M, like this, right? Let me just sort this out. That is that you see that this point here, right? This point. Okay, cool. Let me fix that. Do you see this point here? And I think I'm going to do it in green. This point here, right? Is going to be the midpoint of the two intersections, right? Is that point is going to create the diagonal to bisect each other, meaning it creates a midpoint, meaning the midpoint means the fact that this section here is equals to this, and meaning this is equals to this. So with that is that we can use the midpoint, right? We can use this midpoint. Do you see this midpoint? We can use this midpoint to calculate this, because we already have what M is. We already know the fact that M is equals to 3:0, right? So meaning if I have this coordinate and if I have this coordinate and have this coordinate of the midpoint, is that I can calculate the coordinate of S, right? But the question is, how do we get that coordinate? Do you see the fact that this coordinate of a midpoint is shared by also E and C? If I can find the midpoint using this 2, because I know the fact that it's going to be here, then use whatever answer I get to find this S. Hope that makes sense, right? So finding the midpoint. So the first thing is that we need to find the midpoint of the coordinate. So what we're going to do is that we need to find the midpoint. Find the midpoint coordinate, right? Using what? Using the coordinate A and C, which is going to be -7 and -5, right? So using the midpoint there, midpoint formula, so it's going to be midpoint, right? It's equals to what? Since we're using E and C, it's going to be XE plus XC divided by 2, and this is going to be YE plus YC divided by 2, right? So let's find the midpoint. So we see the fact that it's going to be what? It's going to be -1 plus -7 divided by 2. Then it's going to be what? It's going to be 3 plus -5 divided by 2, right? So you punch that into the calculator. You see the fact that this is going to be -4 is to -1. So that is the midpoint. So we know the fact that this point is what? This point here, right, is negative what? -4 is to negative 1. So now, since we know the fact that this point is that I'm going to basically find the midpoint between S and M, right? But we know the fact that we do not have S, but we already have the midpoint. Then we're going to equate the midpoint to find our S. Hope that makes sense. So let's do that, right? So now, since we have the midpoint, using the midpoint, so let me just do this. Using the midpoint, right, we are going to find S, right? So we know the fact that S is what? I'm going to name it XS and YS. And remember the fact that the diagonal of S is SE. So I'm going to use like finding the midpoint between these two, but we already know the whole point is to find S. Hope I'm making sense, right? So I'm going to need M2. So, and M, which is 3:0, right? So now, with that said, right, we're going to find the midpoint. So it's like we're finding the midpoint. So the midpoint, right, the midpoint is going to be equals to what? It's going to be XS plus XM divided by what? Divided by 2 is to what? Is to YS plus YM, and this is going to be divided by 2, right? So now we're going to substitute the midpoint and also this 2 coordinate. We know that the midpoint is -4 is to what? Is to -1, right? From the previous, right? And now we're going to substitute XS. We don't have, but we have that this is 3 and this is divided by 2, and this is going to be what? It's going to be YS plus 0 divided by 2, right? So now what we're going to do is that we're going to equate the X of the midpoint and the X of what we want, right? So we know the fact that this and this are equal, right? And we also know that this and this are equal. So we're going to equate them to solve for XS and YS. So that's what we're going to do. So we're going to start here. We know that -4 is basically equals to XS plus 3 divided by 2. So now cross multiply. So it's going to be -4 multiplied by 2 is equals to XS plus 3. So this is going to give me -8 is equals to what? 2XS plus 3. Take the 3 to the other side. It's going to be -8 minus 3 is equals to XS. So therefore, XS is equals to -11, right? Then now we're going to solve for the Y coordinate. So we know that -1 is equals to YS plus 0. And this is going to be divided by 2. So it's going to be -1 multiplied by 2 is equals to YS plus 0. So therefore, this is -2 is equals to YS, right? So now our coordinate for S, right, is going to be what? It's going to be -11 is to -2. So that's how you basically calculate what? Calculate the coordinate of S. So now we're going to do 4.6. Let's read the question, right? Let me take my highlighter. And I want it small, right? So it says the radius of the circle is centered at M. We already know that our radius is centered at M, right? So that's sorted, right? But they tell us the fact that it increases by 7 units. So meaning our new radius. So let me just write the new radius. So we have the old radius, right? The old, let me just call it old, right? The old radius is what? It's 5. Remember the fact that when we began by doing the question, I told you that the radius is 5. Let's go up. See, I told you that the radius is 5. So the old radius in our case, let me just go down. Let's go down. Yes, the old radius is 5, right? So they tell us the fact that the new radius, so the new radius increased by 5. So it's going to be 5 plus 7. So it increases by 7 units. So it's going to be the new radius is equals to 5 plus 7. So meaning in total, our new radius is going to be what? It's going to be 7. It's going to be 12, right? So that is going to be our new radius, right? So they tell us the fact that it increases by 7 units. And they continue and tell us what? Let me just take my highlighter. They tell us to determine whether S lies inside or outside the new circle. So the circle still has a center of what? Still has a center of M, but the new radius is 12, right? Because it increased by 7, right? Then they tell us the fact that we need to support our answer with any necessary basically necessary calculation. So I'm going to make it very easy for you. I'm going to give you the general rule on how to determine whether the circle is inside, outside, or on the circumference where it touches the graph, right? So I'm going to call it general rule. So this is going to be the rule that you're going to need to use, right? So this is going to be the general rule, right? So with the general rule, let me just highlight this. So I want this size. So with the general rule is that we need to have the following, right? Is that first we need to calculate the distance, because the distance is the one that we're going to compare on inside or outside. So I'm just going to write everything. So number one is that we need to calculate the distance. So calculate the distance, which is we're going to call it D, right? Between center, right, of the circle. So of the circle, and the given point that they're talking about, right? And the given point. So the given point is going to be, in our case, we are determining whether S. So the given point will be S, right? And the given point. And the given point, right? So let's do that. Of the circle. So of the center. So we need what? We need two coordinates. We need the center and the given point, right? So that's two things that we need, right? So then after that is that we're going to be using the distance formula, right? So using the distance formula. So we're using the distance formula, comma, using the distance formula, right? So that's what we're using, and I'm going to highlight it using the distance formula, right? So now how do we determine whether it's inside, outside, and on the circumference, right? So number one is that if our D, right, which is the one that we used the distance formula, right, is what? Is less than 0, right? That means the fact that the point is inside. So the given, that means the fact that the given point is inside, right? Then if D is equals to R, meaning they're equals to each other, that means that the given point is on the circumference. I'm just going to say at the circum, right? So meaning it touches the circle, right? Then lastly, if D is what? Is greater than R, that means that the given point is outside, right? So that is the general rule. So I'm going to put that inside a block so that we know the fact that this is the general rule. And now we're going to apply our general rule. So now with our general rule, remember the fact that the first thing that we need, what? Is that we need our distance, right? So we need our distance. So with our case is that we need our distance. So we need our distance. First, we need the center coordinate. So we need the center. We know that our center is what? Is 3:0. So it's still the old center. So this is our center, is 3:0. So we need the center, so which is going to be 3. It's going to be 3:0. Then we need the given point. So the given point in our case is what? Is our S, right? Because this one, the one that we're comparing, which is going to be 11. -11 is to -2, right? Then we need our distance. So we know that distance is equals to what? It's equals to the square root of x I'm going to call it 1 here, and this I'm going to call it 2, right? So it's going to be x1 minus x2 all squared plus y1 minus y2 all squared, right? Then this is going to be d is equals to what? The square root, and this is going to be 3 minus 11 all squared plus this is going to be 0 minus 2 all squared, right? So when you punch that into the calculator, you're going to find that your d is equals to what? Is equals to 14 over 4 units. Right? So you have your d. Then we need our r. Remember the fact that our new r is 12, right? So we have that our r, which is, I'm going to say, r new, because that's the one we're comparing it to. We know the fact that that is going to be equals to 12 units. What do we see? We see the fact that d is equals to 14 over 4 is greater than what? It's greater than r, which is equals to 12, right? So what does that match with? We see the fact that this matches exactly with this, meaning that our conclusion is that our given point is outside. What is our given point is S. So with that, we see the fact that what? We see the fact that S lies outside. So that's how you would answer this question. Hope that made sense. So now let's do 4.7. It says if ET is drawn, calculate the angle ETM. So let's draw ET first. So I'm going to go back to red. So ET is connecting this point and this point together, right? So let me just sort that out. So this is ET. Right? So they say the fact that if ET is drawn, we need to calculate which angle. So we need to calculate the angle ETM, right? So we need to calculate the angle ETM. So let's find that angle. So what's ETM? So ETM is ETM. So we're looking for this angle, right? So we need to calculate this angle, right? So we see the fact that this angle lies on this triangle. Do you see that? So it lies on this triangle. So this triangle that I'm emphasizing, right? So that triangle. And one more thing is that I think when we go up, or I don't even need to go up, is that the point from M to T, this is a radius and also this is a radius. Meaning the triangle that I draw is an isosceles, right? Meaning the fact that this and this are equals to each other because they both radius, and also meaning the fact that this angle here is equals to this angle T. So ETM is also equals to this angle because opposite sides equal, opposite angles equals, right? So now that is the information that we have so far. Then now our goal is, how do we calculate this angle, right? Is that since we're dealing with analytical geometry, is that to find angles, the only relationship that we can use, right, is this relationship. So the only relationship we can use is this relationship, tan theta is equals to the gradient. That is the only rule that we can use right now, and a couple of Euclidean geometry, right? But this is the rule that we can use. So we need to find what? We need to find lines, right, that basically cuts the x-axis, right, and basically creates gradients, right? So what is those two lines that can make us basically find that two angles, right? Is that if I do the following, and I'm going to do it with different colors, right? If I extend this line ME, right? So if I extend this line ME, let me go back from here to here. If I extend it, right, we already have the gradient of this line, right? If I extend this line and find what? And find the angle. The angle that I'm going to find for it is this one, right? And what I'm going to do is that I'm going to do it in the color green so that we know what we're doing, right? But we know the relationship of what? Using Euclidean. We know the fact that if I do that is that I can find the angle that's inside, right? Which is going to be this smaller angle using what? 180 minus this angle, because angles on a straight line add up to 180. Hope that makes sense. Then I have a small portion of this angle using this green line. Hope that makes sense, right? But look at this, is that if I extend, remember the fact that I'm using lines that I actually have gradients that cuts through the x-axis, right? Is that if I take this line now, if I take this line here, right? I have the gradient for this line. If I take this line, right? And I find what? I find the angle that you're always finding. So let me just go back and show you with the green one, right? Is that remember the fact that I extended this line? Then the angle that I found is from the positive going like this. Do you see that? So it's always going from like the right hand side going like this is the angle that we always finding. Hope that makes sense, right? So then obviously from there you're going to get this angle, but then you want this one that's inside the triangle, right? So if I find this one that's inside the triangle, it's going to be 180, and I'm going to find this one, right? Maybe before we go to the next angle, let me just calculate that one, right? So what we're going to do is the following. So I'm going to say I'm going to start with that small one. Then after finding that, I'm going to show you on how to find the smaller nyana, ne? Okay, cool. So we're going to say the following. So we're going to say in triangle. So in triangle, MTE. So it's basically the red triangle, right? Is that we know the fact that MT, right, and ME, right, are radius. Are radii, right? So therefore, we know the fact that triangle MTE is an isosceles triangle, right? Meaning what? Meaning like opposite angles equals that, right? So I'm just relating what I said, meaning what? Meaning opposite sides equal. That's like proper Euclidean, right? Equals to opposite angles equal. Hope that makes sense, right? So now using what? Now knowing that, because of that's going to play a role, right? So now using the property, so using what? Using tan theta is equals to m, right? We basically gonna find the angle. So I'm gonna first find the angle what? I'm gonna find the angle of the green line, right? So I'm gonna do it in green, right? So that we know when we're relating everything, we know what we're dealing with, right? So I'm gonna call it angle on line what? Line E. So that's the angle of line EM, right? EM. Right? Remember the fact that when we were doing everything, we already calculated the gradient of EM. Let's go back. Just want to show you the fact that we already calculated the gradient of EM, so that it doesn't look like I am scamming you guys. EM. Remember the fact that we found that the gradient of EM, where is it? EM is -3/4. We already found that, right? So we're going to find what? We're going to find the angle of that line, right? So using the line EM, we know the fact that tangent of theta, right? So this is basically theta. So this angle here is actually theta, right? It's actually theta. So it's going to be equals to what? It's going to be equals to the gradient of EM. But we already know that the gradient of EM is what? It's -3/4. But very important, and I'm going to emphasize it. When finding the relationship of angles, we never use the negative. So we always find the gradient of the positive. So even though our gradient was negative, we always use the positive, right? We know that our gradient was -3/4, but we're going to use the positive version of it. Hope that makes sense, right? So we know the fact that this is going to be the tangent of what? Of 3/4, right? So that means the fact that our tan is 3/4. So therefore, theta is equals to what? Theta is going to be equals to 143,13 degrees, right? But remember the fact that that is the angle outside, right? So that's the angle outside. So I'm going to call this angle alpha, right? So we're going to call that angle alpha the one that we want, right? We know what? We know the following from Euclidean. We know the fact that alpha plus theta plus alpha gives us 180 degrees, and that's angles on a straight line. We know that, right? So now we know that alpha is 143,13 degrees plus alpha, what we want, is equals to 180 degrees. So therefore, alpha is equals to 180 degrees minus 143,13 degrees. So therefore, alpha in our case is equals to what? It's going to be equals to, let me just check, punch that into the calculator. We know that alpha is going to be equals to 36,87 degrees. So this is going to be what? So the smaller nyana alpha is going to be equals to 36,87 degrees. Hope that makes sense. But now is that, remember the fact that we're going to use the relationship of sum of angles in the triangle. So since these two are equals to each other, is that this is simple because of using that, is that we can find what this angle is, right? But our goal is to find this complete angle. Now we need the smaller nyana portion. How do we find the smaller nyana portion? Is that we're going to find it as the following, right? Is that, remember the fact that the line that is related to that is going to be this line. I'm going to relate it with this line. Do you see the fact that it's this line? So let me just, it's going to be this line. Yes, let's extend it. It's going to be this line. So now what I'm going to do, right, is that I'm going to find the angle of that line. So I'm going to find, it's from here to here. So I'm finding this angle here, right? If I find this angle, do you see the fact that using the relationship of Euclidean, this is vertically opposite angle. So meaning this angle and this angle are going to be exactly the same. That's vertically opposite angles, right? So if I find this, I'm going to automatically find that, right? So we're going to call this one beta, right? And maybe this one we're gonna call, let's call it x for the sake, right? So we know the fact that beta and x are equals to each other, right? So that's what we're gonna do, right? So finding beta is that we need the gradient of what? Of the blue line, which is CT or CM, right? So that is the gradient of that line, right? So the nice thing is that we already have two coordinates. Do you see that? We have this coordinate that's been complete and this one. We already know that P is -5, right? So I'm going to find the gradient of CM, right? And use the relationship of this relationship. Hope that makes sense. Then we're going to find this angle, which we know the fact that these two are equals to each other. Hope that makes sense. So let's do that now, right? So go down. So I'm going to do it in blue, right? So now we're going to call it what? Angle of CM. So I'm going to say angle on line CM, right? So we know that the relationship is 10, and I'm going to call it what? I call it beta, right? So it's going to be beta is equals to what? It's equals to the gradient of CM. We don't know what's the gradient of CM. So we know the fact that 10 beta. So I'm going to replace it with the formula. So it's going to be YC minus YM divided by XC minus XM. Right? So 10 beta is equals to what? Is equals to, this is the same as, remember the fact that C is what? C is negative. Let's go up. -7 is to -5. So this is going to be -7 is to -5. Then M, we know the fact that is 3 is to 0. So let's substitute, right? So when we substitute, we're going to have -5, right? -5 minus 0. Then it's going to be -7 minus 3, right? So we know the fact that 10 beta is equals to what? It's going to be equals to 5/10, right? Which is the same as 10 beta is equals to what? Is equals to 1/2. So we're going to say beta is equals to 10 of a half, and you punch that into the calculator, we see that beta is equals to what? It's going to be equals to what? We know that beta is going to be equals to 26,57 degrees, right? So that's what we know. But we know that beta, going back, we know that beta and x are equals to each other, vertically opposite angles, right? Which is what we want, right? So we know the fact that x is equals to beta, and the reason is vertically opposite angles, right? So therefore x is also equals to 26,57 degrees. Hope that makes sense. So now if we go back, we know the fact that this is also going to be what? 26,57 degrees, right? So meaning this angle here, do you see the fact that this angle here is equals to this plus this, right? So now let's do that. So now we know what? We know that, I'm going to go back to my black pen, right? So now we know the following. We know the fact that this angle, so we know the fact that angle EMT is equals to what? So what I'm doing is that I'm saying the fact that angle EMT is equals to angle EMT plus angle what? Plus angle DMT. That's what I'm saying, right? So that's what I'm going to be writing. So I'm saying the fact that that angle there, that's there, right, is equals to angle EMD plus angle DMT, right? So we know the fact that EMT is equals to what? Is equals to the steady, the green one, which is going to be, let me do this so that we can, let me do this. So the green one is this angle, then the blue one is this angle, right? So that we know when we match it. So the green one is 36,87 degrees plus the blue one is 26,57 degrees, right? So we know that that angle there is basically equals to what? Is EMT is equals to what? Is equals to 63,44 degrees. So what I mean is that now this complete angle is equals to 63,44. Then what do we know? Since those two are equals to each other, I'm going to use sum of angles in a triangle to basically solve for this angle, right? So what I'm going to do is that I'm going to say now E, right? ETM, what they want. Remember that the question, they want ETM. So ETM, right? So I'm going to say, let me just show you. I'm going to say ETM plus what? Plus TEM plus EMT, right? When you add them together, it's going to be equals to 180, sum of angles in a triangle. Then we're going to substitute. Hope that makes sense. So let's do that, right? So we're going to say ETM plus what? So it's going to be plus TEM plus EMT is equals to 180 degrees. And the reason is sum of angles in a triangle. Sum of angles in triangle, right? Then now we know the following. We know the fact that, and I'm going to highlight it, right? And I'm going to highlight it in red so that there's consistency. We know the following. We know the fact that ETM and TEM are both equals to each other, right? So since they both equal to each other, I'm going to replace this one by this one, right? Because of that's what we're looking for. So this is the same as having E. And the reason why they are the same, they are equals to each other. Remember the fact that isosceles triangle, opposite sides equal, opposite angle equal, right? So now we know the fact that that two are equals to each other. So since they are equals to each other, so let me just write it maybe. So, but we know the fact that ETM is equals to TEM EM, right? And the reason for that is radii, and is that EM is equals to MT, right? So now I can replace this one, the TEM, by ETM. So we're gonna have ETM plus another ETM plus EMT is equals to 180. So this is the same as having 2ETM plus EMT, which is equals to 180 degrees, right? We know the fact that EMT is 63,44, right? So we know the fact that ETM plus 63,44 degrees is equals to 180 degrees. Take it to the other side, so it's going to be 2 ETM is equals to 180 degrees minus 63,44 degrees. Punch that into, okay, wait, divide both sides by 2. So let's just punch it all at once. So it's going to be ETM is equals to 180 degrees minus 63,44 degrees divided by 2. Punch that into the calculator. We see the fact that ETM is equals to what? Is equals to 58,28 degrees. And that's how you would solve this question. So that's how you would do this. So we're going to do question 5. So question 5, it says if cos theta is equals to negative 5 over 13, and they tell us where theta is between 180 and 360, determine without a use of a calculator the value of, and this is the first one. Before doing anything is that we need to draw a Cartesian plane. So let's do that. So we're going to draw a Cartesian plane. So we're going to draw the Cartesian plane, right? Then we need to determine where the Cartesian plane is lying. So one important fact is that this Cartesian plane, our triangle that we're going to draw, only needs to lie on one quadrant. It cannot lie on two, right? Only one. So the first information, we see the fact that they tell us that our cos is what? Is negative. So where is cos negative? So this is all student. Take coffee. We know that cos is negative in the second and third quadrant, right? But remember the fact that that's two options. We cannot have our triangle in two options. We need to have it in one. So another set of information is this one. Sorry. It's this one, which is this, right? So it's between 180 and 360. So we know the fact that this is 0, this is 90 degrees, this is 180, this is 270, and this is 360. So meaning now, if our if theta is between 180 and 360, meaning the two options will be what? Let me just do it in another color. Our two options will be this and this. But we know the fact that in the third quadrant, in the fourth quadrant, which is this one, it's what? It's positive. So the only triangle, the triangle is going to be in this quadrant, which makes sense because it has both the takeoff, it's negative, and also it's between 180 and 360. Hope that makes sense. So let me draw the triangle. Yes, right. So this is going to be the triangle, right? So we see the fact that they say the fact that theta. So now we need to fill in our triangle, right? So our triangle, this is what? This is a cos, meaning it's adjacent. So adjacent is this one. So it's going to be 5. Then hypotenuse is going to be the one that's opposite the square, right? So we see the fact that we have a negative. Our hypotenuse, right, is always what? Is always positive. So meaning since this 5, do you see the fact that this 5 is on the negative side of x? So this is negative. Hope that makes sense, right? So that is our triangle, right? But what we need to do is that we need to completely basically make sure the fact that all the sides of the triangle are there, meaning we need to solve for this side, right? So this side, right, since it's parallel to the y-axis, it's going to be basically our y, right? Hope that makes sense. And this one, since it's on the x-axis, it's x, and this is going to be represented as what? As r, right? So we're going to use theorem of Pythagoras, but we're going to use it in the form of what you call this, y, x, and r. So this, sorry, so this, the sum, so this, right, is equals to the sum of this squared, all of them, right? So we're going to do that. So we're looking for y, right? So we're looking for y. So how to find y? It's going to be that r squared is equals to x squared plus y squared, right? So we know the fact that r squared is 13. And this is going to be what? This is going to be equals to negative 5 squared plus y squared, right? Take the 13 squared minus negative 5 squared to one side, and we're going to have y squared. So therefore, y, right, if we square root both sides, so y squared, right, and when we square root both sides, it's going to be what? It's going to be 13 squared minus 5 squared, right? So we know the fact that this needs to be what? Plus or minus, right? So every time when you square root, what? When you square root, what you call this? Every time when you square root or you want to get rid of the squared or any positive number, any even number, is that you need to say plus or minus. Hope that makes sense. So this is going to be y is equals to plus or minus, right? Let's clean up this. So it's going to be what? It's going to be 12. So your option is that you have y is equals to 12 or y is equals to negative 12. So we need to pick which one, right? So we see the fact that our y, right, lies on the negative side of the y-axis. So the answer that we're going to take is y is equals to negative 12. So this is equals to negative 12. Hope that makes sense, right? So now we basically sorted out the whole triangle, meaning we can answer the first question. So let me go up. Let me go back to black. So we know the fact that 5.1.1, it says we need to find sine squared theta. So the first thing is that I'm going to basically take the squared outside. So it's going to be the same as sine theta all squared, right? Then now using our triangle, we're gonna find sine square, sine theta. So sine theta is opposite over hypotenuse, right? So it's going to be opposite over hypotenuse. So we know the fact that sine is opposite over hypotenuse all squared. So this is going to be what? Opposite is going to be negative 12 over hypotenuse, that's going to be 13. Right, and that is all squared, right? So now we're going to basically distribute the squared. So this is the same as having negative 12 all squared divided by what? Divided by 13 squared, right? So punch that into the calculator. You're going to have what? You're going to have 144 divided by 169. So this is going to be your final answer for this question. So now we're going to do 5.1.2. It says we need to find 10 360 minus theta, right? So that is reduction. And as you can see, I gave you the reduction whole Cartesian situation happening here, right? So here, let's just basically go through it very quickly. So basically, this is the different options that you get for the first quadrant, right? So this is the different options that you get for the first quadrant, the second quadrant, the third quadrant, and also the fourth quadrant, right? And we know the fact that in the first quadrant everything is positive, in the second only sign is positive, in the third only 10 is positive, and lastly in the fourth is is cos positive, right? So now we need to reduce this, right, into a single trig ratio, meaning we need to single trig ratio means this, right? So it says 360 what? 360 minus theta. We're gonna go to our situation, our quadrant, our situation. I'm just going to call it situation, our reduction diagram. Let me call it reduction diagram, right? And we're looking for 360 what? 360 minus. So we know that 360 minus is this one, meaning it's going to change to negative 10. So that's what we're going to do, right? So the one that I highlighted. So I know the fact that 10 360 minus, so 10 360 minus theta changes to what? It's going to change to negative 10. So it's going to be negative 10 theta. Then now to find 10 theta is that we're going to go back to our diagram. So we know the fact that 10 theta is what? Is opposite over adjacent, right? So we're going to go back. So we see the fact that opposite is this one. So it's going to be negative 12. Then adjacent is 5, right? So it's going to be negative 12 over 5. So this is going to be equals to negative. Remember the fact that this negative, so it's going to be negative 12 over negative 5. So this is going to be minus, this is going to be the same as positive as 12 over 5, because of the two negative sign are going to give me a positive. So therefore the final answer is negative 12 over 5. And that's how you would answer this question. So now we're going to answer 5.1.3. Remember the fact that the question says without a use of a calculator. So with this one is that we need to basically apply our identities, and also we're probably going to use a special angle, right? So the first thing is that I always, and I feel like this is going to be something that maybe you should get used to, is that I love putting all my identities when I'm working with any trig question, is that I always put my identities on the side because I don't know which one I'm going to use. Then I'm going to just zoom it out and check the fact that which identity can I apply here, right? So I see the fact that I have the following identity. So let me go back. Is that it's cos theta minus 135. So I see the fact that the identity that I can apply is this one, right? So let me go back. I see the fact that the identity that I can apply is this one, right? So this is the identity that I'm going to apply here. So let's apply the identity. I'm just going to do this. So I think because I can't go back side to side, what I'm going to do is that I'm going to say what identity I'm applying, right? Applying identity, and I'm going to do the identity, write it. So it's cos, and we have a minus b is equals to cos. So it's going to be cos a multiplied by cos b, right? And maybe let me just unzoom it like this, right? And this is going to be what? It's going to be plus, right? Then it's going to be sine A, then sine B. And I'm going to put it inside a box in red, because that's the identity that we're applying, right? So when applying that identity, we see the fact that A is theta and B is what? It's 135. So let's do that. So we know the fact that cos theta minus 135 is basically equals to cos theta, right, multiplied by cos 135, right, plus sine theta multiplied by sine 135, right? So since they said without a use of a calculator, is that I need to apply some special angle, right? And we see the following. We see the fact that 135 can be written in terms of reduction, meaning I can say 180 minus 45. Because if I say 180 minus 45, so 180 minus 45 is going to give me 135. So what I'm going to do is that I'm going to replace, right? I'm going to replace this 135 by this, so that I can use reduction and I can have the special angle, which is what? Which is 45. Hope that makes sense, right? So let's do that. So we know the fact that this is going to be equals to what? Which is going to be equals to cos theta, like multiplied by cos, and this is going to be 180 minus 45, right? And it's going to be plus sine, and it's going to be sine, and it's going to be 180 minus 45, right? So now using reduction, so I'm going to go back. What I'm going to do is that I'm going to, it's going to be, it's just close by, right? What's 180? So the first one is cos, right? It's cos 180 minus 45. So cos 180 minus 45 is going to be, let's do it in this green color. It's going to be this one, right? And the other one for sine is going to be this one. So we see the fact that for cos it's negative cos theta, and for sine is positive. So we're going to go down and we're going to just fill that in. So we know for cos it's negative, so it's going to be cos theta, and it's going to be minus cos 45, and this is going to be plus sine. I'm seeing the fact that I forgot theta here. Let's move it. This is theta, right? So it's going to be cos theta, and this is going to be what? This is going to be sine 45, right? So now we got that, right? So now this is basically what you call this this is basically a special angle, right? So the special angle is that it takes up this triangle. So I'm gonna just draw the triangle. So let me just have the triangle here. So this triangle, right? And this is the triangle where the hypotenuse is √2, right? And this is 1 and this is 1, and 45 is here, and also another 45 is here, right? So this is our 45, right? So now applying this triangle, we see the fact that this is going to be cos theta. Then what is cos 45? So cos 45 is opposite, which is 1 over hypotenuse, which is √2. So let's that. So it's going to be what? It's going to be minus what? 1 over √2, right? Then this is going to be plus sine theta, right? It's going to be what? Sorry, I made a mistake. Yeah. Even if it's going to be 1 over √2, I made a mistake when I found cos. So we know the fact that cos theta, right, is what? Is adjacent. I said opposite. So it's adjacent. So it's going to be 1 over √2, right? Which is this one. So it's going to be 1 over √2, right? Then this is going to be plus sine theta, and it's opposite over hypotenuse. So this is going to be opposite over hypotenuse. So it's going to be still 1 over √2, right? So now we have filled in for the special angle. Now we need to fill in cos theta and sine theta. So going up, we already know that cos theta, if we go up, we know that cos theta is negative 5 over 13, right? So it's this one is basically what we were given. Then sine theta, we already know the fact that is negative 12 over 13, right? So now let's basically put that in, right? So we know the fact that 2. So now let's fill them in. So when we're filling them in, we're going to have the following. This one is going to be negative 5 over 13. And this is going to be negative 1 over √2, right? Plus sine is what? It's 13, right? It's negative 12 over 13. And this is going to be 1 over √2. So simplifying it, here we're going to say numerator multiplied by numerator and denominator multiplied by denominator. And we see since they both negative, it's going to give me a positive. So this is basically going to be what? It's going to be 1 multiplied by 5, which is going to give me 5, right? And the negative and negative is going to give me positive. And 13 multiplied by √2 is going to give me the same as 13 √2, right? And this is going to be what? This is going to be plus, now let's sort out this one. It's going to be numerator plus numerator, which is going to be 12 multiplied by 1, which is going to give me negative 12 because this negative. And 13 multiplied by √2 is going to give me 13 √2, right? So now this is going to be 5 divided by 13 √2. And the negative here is going to cause the positive to become a negative. So it's going to be minus 12. Then it's going to be 13 √2. The denominator is the same, so we can basically subtract the what? We can subtract the numerator. So it's going to be 5 minus 12 divided by 13 √2, right? So therefore, this is going to give me what? This is going to give me, when you say 5 minus 12, right, it's going to give you negative 7. So it's going to be minus 7 divided by 13 √2. And that's how you would answer this question. So now we're going to do 5.2. It says simplify the expression to a single trig ratio, and they give you this expression, right? So within this expression, we see the fact that there is a lot of reduction. So what I'm going to do is that first I'm going to basically take out the square root here. So let me just do this. I'm going to take out the square root here outside. Then I'm going to apply the the reduction, right? Using the reduction diagram. Hope that makes sense. So now let's do this. We know the following. We know the fact that this is 2 cos, and this is going to be 180 theta minus x, and this is going to be sine, and this is going to be minus x, right? And this whole thing is divided by what? This is divided by 1 minus 2. Then I'm going to take out the square root, so it's going to be cos, and this is going to be 90 minus x, right, all squared. So that's what we have, right? So I'm going to apply what, I'm going to apply the reduction on the following. So on this one, right, on this one, and finally on this one, right? So that's what we're going to do. So now let's start with the green one. So we know the fact that cos 180 theta minus 180 minus x is going to be equals to, so that's the green one. So I'm going to just go to my diagram. I'm going to look for 180 minus x. So cos 180 minus x, cos 180 minus x is this one. It's going to give me what? It's going to give me a negative cos. So this is going to give me minus cos theta, right? Then we're going to move to sine, and negative x, right, is going to be equals to, move to my diagram. I see the fact that that is going to be what? That's the blue one. It's going to be this one, right? And just a quick note on this one is that if you have a negative angle, right, only cos is positive, and 10 and sine are both negative. So that is going to give me a negative. So that's going to be minus, it's going to be minus what? This is going to be minus sine theta. Then lastly, we're going to have cos, and this is going to be 90 minus x. That is a cofunction, meaning cofunction, it changes from cos to sine, and if it's sine, it changes from sine to cos. So if we go to the diagram, 180 minus, right, 180 cos cos 90 minus theta is going to be this one. It's going to be this one, right? So meaning it's going to be positive sine theta. So this is going to be replaced by sine theta. So with that said, is that now we can fill in. So when we fill it in, it's going to be 2. Then this becomes negative cos theta, right? From the green one, this one. And this is going to be multiplied by negative sine theta. Sorry, why do I keep on saying theta? It's x. I think I kept on writing theta because of the diagram. This is x, this is x, and this is x. Sorry about that, right? So this is going to be x, right? And this is going to be negative sine x, right? And this whole thing is going to be divided by what? This is going to be divided by 1 minus 2, and this is going to be sine x, and this is going to be all squared. So simplify that, right? So let me put this maybe in a box so that it doesn't confuse you guys. Yes, maybe make it this. Yeah, right? So this is going to be what? When we simplify it, it's going to be 2. A sine and a sine is going to give me a positive. So this is the same as cos x multiplied by sine x, right? And this whole thing is going to be divided by 1 minus 2 sine squared x, right? So still we need to simplify it. So if we go up, right, and if we go up, is that we see the fact that this comes from these two identities. There's two identities here. Do you see the fact that there's two identity? And let me just pull this up because I want to compare it when we add that side. So duplicate it, cut, right? So let me just put it here. If it's going to fit. Yes, it's going to fit, right? Is that the numerator, right? The numerator is exactly like this one. And maybe let me just do it in a different color so that we can match it up, right? So you'll see the fact that the numerator, it's exactly this one, right? Is that we know the fact that with multiplication, cos and sine can swap places, but it's exactly this one. Meaning I'm going to replace the numerator by sine 2x. Hope that makes sense. Then we see that the denominator, right, this one, it's exactly like which one? It's exactly like this one. So meaning I'm going to replace it by what? I'm going to replace it by cos 2x, right? So this is basically equals to sine 2x, and this is going to be cos 2x. That is an identity. Which identity it is, I don't know whether to have enough colors by now, but it's this identity. Do you see that? It's this identity, this. So I'm going to replace it by that. Do you see why I'm saying having all the identities on the side matters? Because now I can replace it by what? By that. So we know the fact that this is going to be 10 to x, and that's going to be your final answer for this question. Hope that makes sense. So now we have 5.3. It says calculate the value of the following expression without a use of a calculator, and they give you the expression. So this is the expression. So let me just rewrite it again. We have that 10, 92, right? Then it's going to be 10, 94. Then it's 10, 96, right? And it continues till 10, 106, 176. Then it's 10, 178, right? So now, looking at it, the only identity that I can put in, maybe that's going to make a difference because of its division is going to cancel things, is this identity, right? Is this identity. So I'm going to just apply that identity. So let's apply it. So we're going to have, this is the same as now, sine 92 divided by cos 92. Then we have sine 94 divided by cos 94. Then we have sine 96 divided by cos 96, right? And it continues, and we're going to have sine 176 divided by cos 176. Then lastly, we have sine 178 divided by cos 178, right? Then now, another thing that we could do maybe while doing, we'll see the fact that we're going to have common things, is reduction, right? So what I'm going to do is that I'm going to take all the numbers. So I'm going to start with the 178 going down, writing them on the side, and see the fact that when I reduce them, what do I get, right? So we see the fact that we're going to have 176, then it's 178, then we have 96, then we have 94, then we have what, 92, right? So the nice thing is that here, when I reduce it, right, if I say 180, right, 180 minus 4, I'm going to get 176. This one, when I say 180, right, and we're doing just a trial and error, right? But we're going to start with the one that's closest to the number, which is 180, right? So when I say 180 minus what? When I say 180 minus 2, right, here, is that I'm going to use my cofunctions, right? So using my cofunctions is that here, I know the fact that if I say 90, right, if I say 90 plus 6, and this one is going to be 90 plus 4, and here is going to be 90 plus 2, right? So the nice thing about cofunction is that it changes to what we have already, which is going to be a cos or a sine. So it doesn't like complicate anything if we change. So we see a pattern on the side, right? And I'm going to mark the pattern, right? Is that we see the fact that we have a 4 here and I have a 4 here, meaning some cancellation or something is going to happen, whether cancellation or addition, which is, I don't think addition is going to happen because of we multiplying everything. So meaning some cancellation when we reduce this is going to happen because we have a 4 and a 4. We also see the fact that we have a 2 and a 2, right? Then with the 6, you're probably asking yourself, oh my God, what's happening, right? Is that with the 6, is that if I add, do you see the fact that here, right? On the first part is 3 of them, but here is 2. But here, if I add another one, like in front because of it ends here, I can add after because of this is the final one. If I add another, another 10 right here, right? Here is that you'll see the fact that that is going to be our 4, our 6, the one that's pairing with our 6, right? So if I do the following, let me just do it. If I say, do you see the fact that there's a pattern? This is 92, 94, 96, right? And this is 178, 176, meaning the number before this is going to be 174. And if I say 180 minus 6 is going to give me 174. So now, meaning 6 now has a partner. Do you see that? 6 as a partner, which is this 6 and the 6. So what I'm going to do is that now I'm going to implement this 174. Let me do that, right? So implementing it is going to be like this. So now we're going to have what? We're going to have sine 92 divided by cos 92 and sine 94 divided by cos 94. Then we're going to have sine 96 divided by cos 96, right? And dot, dot, dot. Then this side now we're going to start with sine 174 divided by sine 174, right? And you know what? This is too much writing. So I'm just going to copy this, duplicate it, and I'm going to paste it. So this is here. Paste this. Yes. Right? So we're going to have that. So now the nice thing is that I can now replace. Do you see the fact that the 90, all these numbers? So basically what I mean, all these numbers, I'm going to replace it by this. Hope that makes sense. So that's what we're going to do now, right? So for what you call this, for 92, it's going to be what? It's going to be the same as sine. Then this is going to be 90 plus 2, right? So it's going to be 90 plus 2. Then this is going to be cos 90 plus 2. And here's going to be sine 90 plus 4. And it's going to be cos 90 plus 4, right? And here's going to be what? It's going to be sine 90 plus 6. And it's going to be cos 90 plus 6, right? And dot, dot, dot. I'm just going to do this ones on the next line because there isn't space. So it's going to be, here's going to be what? It's going to be sine. It's going to be sine 180 minus what? Minus 6, right? And this is going to be sine 180 minus 6, right? And it's going to be sine 180 minus 4. So it's going to be 180 minus 4. And it's going to be sine 180 minus 4. Then lastly, it's going to be sine 180 minus 2. So it's going to be 180 minus 2. And lastly, it's going to be sine 180 minus 2. Right? So now, since that we know the fact that that is reduction, right, is that we need to know what is 90 plus, right, what happens to the 2, and also it's going to be what? It's going to be 90 plus and 180, right? So I'm going to just pull up this diagram. So I'm just going to take this diagram. Let me just do this. Yes. So I'm going to pull out this diagram, duplicate it, cut it, and I'm just going to put it here. Then I'm going to erase the parts that I don't want. Okay, let me do this. Okay. Yes. All right. So we need 180. Made a mistake. See, I made a mistake. This is sine. I kept on saying cos. This is cos. Cos and cos. Sorry about that. Let me just check. Okay, cool. This is sine, cos, sine, cos, sine, cos, sine, cos, sine, cos, sine, cos. That's good, right? So we're going to start with 90 plus, right? So we see the fact that we have sine 90 plus, 90 plus. So 90 plus, sine 90 plus. Let's do this because I like color coordinating. So we know the fact that the 90 plus is going to be the yellow, right? And the cos is going to be this one. So for the yellow, right, which is going to be the 90 plus, is going to be this one. It's going to change to cos, right? Then for the green one is that this one is going to change into negative sine theta. So let's replace that one, right? So this is basically going to be equals to Didn't even say put in equal signs. Yes. So this is going to be equals to. So this, we see the fact that our sign becomes cos. So it's going to be positive, and very important, positive, right? So this is going to be replaced by what? This is going to be replaced by cos 2, right? And the denominator is going to be negative sign 2. Then this is going to be replaced by cos 4, and it's going to be negative sign 4, right? Then this is going to be what? Then this is going to be cos 6. That's going to be minus sine 6, right? Then now we're going to apply 180. So I'm going to make it in a different color. So blue is going to represent sine 180, right? So this is going to be that. Then the purple is going to represent for the cos, right? So let's start with the blue one. So sine, going in the diagram, is going to be 180. We see the fact that all of them are going to be positive. Then we see the fact that for cos, all of them, they're going to be negative. So let's apply that, right? So when applying it, I'm just going to apply it here. So let me just do this. I need space. If I can. Yeah. Yes. Right. So now we're going to have what? We're going to have that all the numerator are going to be what? Are going to be positive. So it's going to be sine 6, and this is going to be negative cos 6, right? And this is going to be what? It's going to be sine 4. Then this is going to be minus cos 4. Then lastly, we're going to have sine 2, and this is going to be negative cos 2, right? So we're going to have that, right? Then we see something. We see the fact that since everything is multiplying each other and there's also division, meaning cancellation is going to happen, right? So we see, I'm going to mark the ones that are going to cancel. We see the fact that there's 2 here and this one. Maybe let's do it like this, right? We're going to do it with a different color. So we know the fact that this and this are going to cancel each other, which is great, right? Then we also see the fact that this sign here is going to cancel with this one. Do you see that? So we see the fact that the one that's in the denominator and numerator, they're going to keep on canceling. And if we do all of them, you see the fact that there's going to keep on being cancellation. So this one and this one, right? Also, we see the fact that this one is going to cancel with this one. And just keep on doing that, right? This one is going to cancel with this one and this one. So this one and this one and this one and this one. So we see the fact that everything is going to cancel each other, right? So with everything canceling each other, when we're dealing with multiplication and the numerator and denominator canceling each other, that means now our answer is equals to 1, because everything is the same in the numerator and denominator, meaning if we have the same in the numerator and denominator, that means the fact that that's equals to 1. So meaning this, I'm just going to show the cancellation, right? So this and this are going to go, right? And this and this are going to go. Then we see the fact that this is going to go with this, right? And the sign is going to go with this one. Do you see that? And this is going to go with this one. And finally, this is going to go with this one. So that means the fact that this is equals to 1, right? Because meaning the numerator and the denominator, it's exactly the same thing. That's why they're all canceling each other. So therefore, this is going to be equals to 1. And why I'm saying it's equals to 1, and I know the fact that I'm rambling, is that remember that rule, the fact that if we have 8 divided by 8, this is the same as 1. So that's what I'm saying, is the fact that the numerator and denominator, since everything is canceling, it's equals to 1. Hope this made sense. So now we're going to do question 6. It says prove that 2 cos squared open bracket 45 degrees plus theta is equals to 1 minus sine 2x. So looking at this is that we are proving, so we need to prove that the left hand side, right, which is this one, is equals to the right hand side, which is this one, right? So from the first thing that I see, you need to say take the most complex one and basically reduce it so that it looks like the other side, right? So I'm going to take the left hand side because for me, I feel like that is the one that I can like simplify further so it looks exactly like the right hand side, right? So taking the left hand side, so I'm gonna name it left hand side. We know the fact that that's 2 cos squared, and this is going to be 45 degrees plus x, right? So now what I'm going to do is that I'm going to take out the square outside. So this is going to be the same as 2 open bracket cos, and this is going to be 45 plus x, right? And this is going to be all squared. And if you look at this, you'll see the fact that this is exactly this identity. And I'm just going to go up. Yes, we're going to look at the identity. It's going to be exactly like this identity, right? This identity is going to be exactly that. So there's where I said applying this identity. So I'm going to copy and paste that and basically write it at the bottom. Duplicate, cut. Let's go down, right? So applying, so I'm going to paste this, applying this identity, right? When we're applying that identity, we're going to have the following. We're going to have 2, and inside the bracket is going to be cos 45. So our A is going to be 45, and our B, right, is going to be what? It's going to be x. So I'm just going to replace this by a positive, and this doesn't become a positive. This is going to become a negative. So let me just do this. This becomes a minus, right? And let me just put in that filter because of that is the identity that we apply. Yes. Yes. Okay. So now we can apply it. So our A is what? Our A. Let me do this. Go back. So this is plus. Yes, right? And this is going to be negative. Hope that makes sense, right? I hope I didn't lose anyone. So I wanted to say the fact that our A is going to be 45 and our B is going to be x. So this is going to be cos what? This is going to be cos. So this is going to be 2. Then this is going to be cos 45 multiplied by cos x, right? And this is going to be minus sine 45, then multiplied by sine x, right? And this is going to be all squared, right? Then now we're going to have the following is that 45 is what? Is a special angle, right? It's a special angle. Remember the fact that when we were solving up, let me just go up. We saw the fact that both cos and sine 45 is 1 over square root of 2, right? So it's from this special angle using this triangle, right? So I'm not going to rewrite it again. So we know the fact that this, both cos and sine is going to be what? It's going to be 1 over root 2. So we know the fact that this is going to be 2. Then this is going to be 1 over root 2. Then this is going to be cos x. And this is going to be minus. Then it's going to be 1 over root 2. Right? And this is going to be sine x. And this is going to be all squared. Right? So that's what we're going to have. So now what we need to do is that we need to basically, what I'm going to do is that I'm going to pull out the 1 over root 2. Right? So let's do that. So let's going to be 2. And I'm just going to put in the square bracket, right? So it's going to be 1 over root 2. So I'm going to be left with cos x, right? Minus sine x, right? And this is going to be what? This is going to be all squared. Hope that makes sense. Then now I'm going to distribute the squared here and here, right? So that the 1 over root 2 can be alone. So this is the same as 2. And this is going to be the same as 1 over root 2 all squared, right? And this is going to be cos x minus what? Minus sine x, right? And this is going to be all squared. Hope that makes sense, right? So this is going to give me what? This is going to give me 2. And this is going to be 1 over root 2 is the same as 1 over 2. So it's going to be 1 over 2. And this is going to be cos x minus sine x, right, all squared, right? So this 2 multiplied by a half is going to give you 1. So this is the same as having cos x minus sine x all squared, right? So now we're going to expand it, right? So when we expand it, right, we're going to have the following. So when we expand it, we're going to have the following. We're going to have cos squared x, right? Then this is going to be minus, so it's going to be minus 2 cos x multiplied by sine x, right? And this is going to be plus sine squared x. So when we expand that, right? So what do we see? We see the fact that we have another identity. We have this identity. So if I take the cos squared x plus sine squared x, right? So cos squared x, right, plus sine squared x is going to give me a 1, right? So that's an identity. So then minus 2 cos x multiplied by sine x. So what I'm going to do is that applying the following identity. So applying the following identities, right, is that we have the fact that cos squared x, right, plus sine squared x is going to give me 1, right? Then another identity is that this one, which is going to be 2 sine x multiplied by cos x, right? It gives me 2, what you got it? It gives me sine, let me go back, it gives me sine 2x. And just to make it a little bit simple is that I'm going to highlight which one is going to apply. So for the purple one, it's going to apply for this one. So I'm going to replace it by that one, right? Then for the green one, it's going to be this whole thing is going to be replaced by this. Hope that makes sense, right? So I'm just going to put this inside a block. Put it in red, right? So that we know. So now we know the fact that cos squared x plus sine squared x is going to be replaced by 1. And this is going to be minus what? Minus sine 2x. Hope that makes sense, right? And when we go back, we see the fact that that is exactly what the right hand side is equals to. So this is equals to the right hand side, meaning that the left hand side is equals to the right hand side. And we have proven this identity. Hope this makes sense. So now we're going to do 6.2. It says consider the expression, and they give us the expression, right? And they say the fact that we need to prove that this expression, the left hand side, is equals to that, right? So that's what we're trying to prove. So again, that's proving, meaning we need to prove that the left hand side, which is this side, right, is equals to the right hand side. So the one that we can simplify further is the left hand side. So I'm going to take the left hand side again, which is going to be sine, and this is going to be a minus b, minus this is going to be sine a plus b. We see the fact that by just looking at that, this is the two identities. Let's go up. We see the fact that this is exactly, the nice thing is this is exactly those two identities. So I'm going to be applying the two identities, right? So applying the two identities, I'm just going to take the sign, just going to take one at each time, right? So I'm going to apply this identity, which is sine a minus b, right? Which is going to be equals to sine a multiplied by cos b, right? Minus, and this is going to be cos a multiplied by sine b, right? So then we're going to have sine a plus b, which is going to give me sine a multiplied by cos b plus cos a multiplied by sine b, right? So let's replace them. So when we replace them, we know the fact that this is going to be equals to, so the a minus was going to be sine a, let me just do this instead of writing. I'm going to take the first one and replace it by this one. So duplicate, cut, right? Then this is going to be minus. Remember the fact that the minus is from here. So it's going to be minus. I'm going to open a bracket and I'm going to replace the sine a plus b by this one. So let me just take it just like this. Duplicate, cut. And we're going to just put it here. Just like that. Then I'm going to close the bracket, right? Then what I'm going to do is that this one, I'm going to rewrite it the way it is. So I'm just going to take this, duplicate it, cut, right? Because it's repetition. Then here I'm going to distribute the negative. So it's going to be minus sine a cos B. And this is going to be minus, because minus and a positive is going to give me a negative. So it's going to be cos A multiplied by sine B. Then now I'm going to group like terms, right? So looking at it, I'm going to group like terms. I see that this looks exactly like this one. And I also see the fact that this looks exactly like this one, right? We see the fact that this one is positive, the green one. This one is positive and this one is negative. And it's the same thing, meaning they're going to cancel each other because it's going to give me 0. And these two are both negative, meaning it's going to be minus. So the yellow one is going to be minus 2 because we're going to add them. So it's going to be cos A multiplied by sine B, right? Then what do we see? We see the fact that, yes. And we see the fact that if we go back, that is exactly what it equals to. That is exactly the right-hand side. So this is equals to the right-hand side. And that's how you will solve this question. Hope that makes sense. So now let's do 6.2.2. It says simplify the following expression in a single term, right? Single term and single ratio is not the same thing. What is single term? Let me show you. Let me show you the fact that this is 2 terms. This is 1 term and this is another term. So we want to make this into a single term. So a single term looks like this. Do you see the fact that here we have 2 terms, right? A single term is basically like this. So we don't want anything to be adding or subtracting the other term. So that's a single term, right? So our goal is to basically write this into a single term. So going back to that is that, do you see the fact that this looks similar to what we given? So it looks similar to this. So it looks very similar to this, and I'm just going to copy and paste it. It looks very similar to this. So duplicate, cut, right? It looks very similar to this, and I'm just going to write it here, and I'm going to rewrite what they want us to change into a single term, which is going to be sine 4x minus sine 10x, right? So we see the fact that they look more or less similar to each other, right? So meaning this and this are the same. So here what happened is that they changed this a minus b into 4x, and they changed this a plus b into 10x. Hope that makes sense, right? And the nice thing is that already this one, and let me just put it in a box, right? Already this one, right? We know what it looks when it's a single term. So we know the fact that this is basically equals to what? Is equals to negative 2 cos A multiplied by sine B, right? So now what do we want to do? Our goal is to solve what? Is to solve our A and B in terms of x so that we can write this one into a single term. So let's do that, right? So let me just write that. So our goal is to solve so our goal is to what? Our goal is to solve A and B, right? In terms of x, in terms of x, right? So we can write sine 4x minus 10x in a single term. Hope that makes sense. So what do we know? We know the fact that if this and this are eventually more or less the same thing, it's just that this is changing. To solve for our A and B, right, in terms of x, we can equate these two together, right, and create 2 equations so they can solve A and B. So that's what we're going to do, right? So I'm going to take, we know the fact that the yellow one, which is going to be 4x, is equals to A minus B, right? Then I'm going to make A the subject, so it's going to be 4x, right, plus B is equals to A. So this, I'm going to name it equation 1, right? Then the second one is going to be 10x is equals to what? To A plus B. So it's going to be A plus B. And I'm going to then name this equation 2. So what we're going to do is that we're going to substitute equation 1 into equation 2. So that's what we're going to do, right? So wherever now in equation 2, wherever I see a, I'm going to substitute by what? I'm going to substitute by this whole thing. That's what I'm going to do. So I'm going to say what? I'm going to say 10x is equals to, then a is going to be substituted by 4x plus b, and this is going to be plus b, right? So hope that makes sense. So now let's simplify this. This is going to be 10x is equals to 4x. Then a b and a b is going to be plus 2b. Take the 4x to the other side. So it's going to be 10x minus 4x is equals to 2b. And this is going to give me what? This is going to give me 6x is equals to 2b, right? Divide both sides by 2. So it's going to be 6x divided by 2 is equals to b. So therefore, our b is basically equals to what? It's going to be equals to 3x, which is good, right? So we have that, right? Now we're going to substitute our b into equation 1, right? Because of equation 1, it's already in terms of a, right? To solve for our a. So now we're going to substitute b into equation 1. So we know that equation 1 is what? It's a is equals to what? A is going to be equals to 4x plus b. So it's going to be 4x plus b. So this is going to be the same as a is equals to 4x plus 3x. So therefore, a is equals to 7x. So the nice thing is that we already have what? We have everything. We have our a and b in terms of x, right? So I'm going to take whatever that we have. I'm going to take this one. So what I'm going to do is that I'm going to take this one, right? So I'm going to duplicate it. You'll see what I'm going to do so that I don't want to confuse you guys. I'm going to take this. I'm going to paste it here, right? We already know the fact that this, right? We already know the fact that a minus b is what? Is 4x, right? So I'm going to rewrite it. So we know the fact that this is sine a minus b is 4x. And we know the fact that a plus b is 10x, right? So it's going to be sine 10x. Then here it's going to be minus 2 cos. We already solved that a is 7x. So it's going to be replaced by 7x multiplied by sine. And we know the fact that b is 3x. So this is going to be 3x. And this is going to be your final answer for this question. So this is going to be your final answer for this question. Hope that makes sense. So that's how you would solve this question. So now we're going to solve 6.2.3. It says, hence determine the solution for sine 4x minus sine 10x is equals to sine 3x4 when x is between 0 and 30 degrees, right? So we're solving for x, right? So we know the following. We know the fact that this, remember the fact that this can be written in the single trig ratio, which is this one, right? So I'm going to replace this by this, right? Then we're going to solve for this question, right? So let's do that. So what I'm going to say is that from 6.2.2, right? We know the following. We know that sine 4x minus sine 10x, right? It's equals to what? It's equals to negative 2 cos 7x multiplied by sine 3x. So that's what I'm going to do. I'm going to replace, let me highlight it. I'm going to replace this whole thing by this. That's what I'm going to do, right? So now this is going to be our updated. It's going to be sine, let me rewrite it, 4x minus sine 10x is equals to sine 3x. So updating it, it's going to be negative 2 cos 7x, right? Multiplied by sine 3x is equals to sine 3x. And again, the nice thing is that in our equation, they said hence, meaning we need to use whatever that we used previously to solve this equation. Hope that makes sense, right? So now with this is that I can't divide both sides by 3x because we're going to lose one of our solution. So what I'm going to do is that I'm going to take the 3 to the other side and take it out as a common factor, right? So we have the fact that negative 2 cos 7x multiplied by sine 3x minus sine 3x is equals to 0. Take out sine 3x as a common factor. So it's going to be sine, let me just do this. This is going to be sine 3x, open bracket, we're going to be left with negative 2 cos 7x minus 1 is equals to 0, right? So equate them, sine 3x, and the bracket would, equate them to 3, equate them to 0, sorry. So this is going to be sine 3x is equals to 0, or it's going to be negative 2 cos 7x minus 1 is equals to 0, right? So let's start with this one. So with this one is that we need the reference angle. So we see that the reference angle is going to be what? It's going to be arc sine. So it's always going to be arc the trig ratio, right? Then this number that you have, right? So it's going to be arc sine of 0, and we see the fact that our reference angle here is equals to what? Is equals to 0, right? So since it's equals to 0, this is the same as just taking this angle and equating it to the reference angle. We don't need to check where sine is positive or negative because it's 0. Hope that makes sense, right? So this is going to be 3x is equals to 0. Divide both sides by 3, so it's going to be 3 is equals to 0 degrees. So this is one of our solutions, right? So we sorted with that one. Now let's deal with this one, right? So first we want the trig ratio, we want the ratio, right? The trig ratio to be alone. So I don't want this 2 and I don't want this 1. So let's do that. So it's going to be negative 2 cos 7x is equals to, take the 1, so it's going to be positive 1. So divide both sides by by negative 2. So you're going to have cos 7x is equals to what? Is equals to 1 over negative 2, right? So now we're going to find the reference angle. So we're going to find the reference angle. So the reference angle is going to be arc of this trig ratio, right? Then the positive of this. Never put the negative. Very important. Never put the negative. So it's going to be arc cos of a half, right? Which that you're going to get as being equals to 60 degrees. So that's our reference angle, right? So now what we're going to do is that we need to basically know where our solution is going to lie, right? So I'm going to just draw a quick diagram here, right? And this is going to be all student take coffee, right? So here it's going to be what? We only deal with what? With 180, right? Minus or plus, and also 360. That's the only one that we deal with general solution, right? So this is going to be what? This the first one, since this is 90, 0, this is going to be 180, this is going to be 270, and this is going to be 360. So here it's going to be what? This can be 360 plus, or it can be just theta, right? So I like dealing with theta and negative theta. So here our option is theta, right? And this is going to be plus it's going to be theta plus, right? So wait, let me just theta, right? Not plus k. Then here it's negative theta. I like dealing with theta and theta or negative theta. Or here, if you don't want to use theta, right, is that you can use 360, right? So it can be 360 because it's going up. So it's going to be plus theta. Then here you can use 360 minus theta. Hope that makes sense, right? So that's the two options that you have, right? Then now we're going to move to the 180. So here going up is going to be 180. 180 what? 180 minus theta. And here's going to be 180 plus theta. So for the general solution, that's the options that you have, right? So now looking at it is that how do we know which quadrant we need to deal with, right? We see the fact that here, do you see the negative sign that I told you do not put in when you're looking for the reference angle? This tells us where our solution lies, right? We see the fact that it's negative. So where is cos negative? Cos is negative in the second and third quadrant, right? So cos is negative in the second and third quadrant, meaning our answer is going to be 180 minus theta, then 180 plus theta. And since they gave us the fact that the restriction is between this, right, is that I don't need to say plus k 360 because that's not the general solution. We're just solving for x. So I don't need to put that, right? So our solution is between two quadrants. So it's either in the second quadrant. So it's going to be in the second quadrant, right? So it's in the second quadrant. And in the second quadrant, it's going to be the angle. So in our case, we see the fact that our angle is what? Our angle is 7x. So we're going to say 7x. Do you see the fact that with this one, when we were solving, it was 3x, right? So it was 3x. In our case here, it's 7x, right? So you're going to say what? You're going to say 7x, right, is equals to, in the second quadrant, it's 180, right, minus, what is this theta? Do you see this theta here? That's our reference angle. So it's going to be 60. So that's going to be 60, right, degrees. Then when you solve this, this is going to be 7x is equals to, 180 minus 60 is going to give you 120, right? So it's going to be, x is going to be 120 divided by 7. Therefore, x is going to be equals to 17,14 degrees, right? So that is for the second quadrant. Or our solution is going to be in the third quadrant, right? So in the third quad, it's going to be what? It's going to be 7x, and it's going to be 180 plus. So it's going to be 180 plus our reference is 60. So this is going to be 7x is equals to what? Is equals to 240, right? Divide both sides by 7. So x is going to be equals to 240 divided by 7. So therefore, x is going to be equals to 34,29 degrees, right? Then we see something. We see the fact that, do you see the fact that when we were solving, our restriction became very clear, the fact that our answer needs to be between 0 and 30 degrees. So this is a solution, right? Let me just highlight the solution, right? In green. We see the fact that this is a solution, this is a solution, but this is not a solution. This is not a solution because of this is not between 0 and 30 degrees. So our final answer is going to be what? It's x is equals to 0 and x is equals to 0 and x is equals to 17,14. Hope that makes sense, right? So that's how you would solve this question. So now let's do question 7. It says in the diagram, we have the graph f of x, and they tell us the fact that this f of x is this graph. I like, very important, and I feel like maybe it's like a thing that everyone should do, is that highlight your two graph because of it gets messed up, right? But I love highlighting. So I know the fact that f of x, let me just make this small. I know that f of x is this one, meaning this is going to be f of x, right? So I know that f of x is my green graph. So it's going to be this green graph, right? So that's f of x. And they tell us the fact that g of x, right, is this one. So it's going to be the sine one. So I have my g of x, right? So I'm going to have my g of x just being this one, right? I've drawn with the interval between negative 180 till positive 180, right? Then the first question, it says, write down the range of f. I like giving formulas, so I'm going to give you a formula. So you know the fact that we have the general form. What I'm giving you, it's quick notes, then we're going to apply the notes, right? We know the fact that, and this note is both for if you asked for the range of either a cos and a sine, right? We know the fact that the general form of a cos is y, right, is equals to what? Is equals to a cos. Then this is going to be bx plus what? Plus p, then plus q. And also the same thing with sine is going to be a sine. Then this is going to be bx plus p, right? And this is going to be plus q. That's the general form of it, right? So to find the range, this is the following. This is the formula that you're going to use. It's going to be the range. It's going to be basically equals to y is an element, square bracket. Very important, square bracket. And this is going to be minus what? This is going to be minus, this is going to be minus the absolute of a, right? Then this is going to be plus q, right? Then this is going to be positive. So it's going to be positive, the absolute of a again, plus q. So you minus the absolute of a, then b, basically the positive version of it. Now let's ask what is absolute. And I'm just going to do quick notes here, right? absolute of any number is that you're taking any number and you always make it positive. So for instance, the absolute of 2 is equals to 2. And also the absolute of maybe -3 is equals to +3. So any number, if it's positive or negative, the absolute means the fact that we just want the positive version of it. So one more is that the absolute of -11 will give you 11, right? Hope that makes sense. We're just taking it from being a negative or positive. It still becomes a positive. Hope that makes sense. So I'm just going to put this into our block because that's our quick note, right? Now we're going to apply it, right? So we see the fact that we want the range of f, and f is cos, right? So what do we need? We need a, we need q, right, to find our range. So in our case is that we're looking for our range, right? And we know our range is going to be y is an element of the negative, the absolute of a, right, plus q. Then it's going to be absolute of a plus q. That's what we're looking for. So we need a. So we need a. We're going to go back to our function. A is the one that is what? That is the coefficient of what? Of the trig ratio, which is 2. So in our case, a is 2, right? So we see the fact that it's from here. A is 2, right? And we need q, right? Q, if you look at it, is the one that is like outside. So it's like the trig ratio plus that number that is q. So in our case, q is 1, right? So we see the fact that q is 1. So this is going to be 1. So this is going to be q is equals to 1. So now let's apply it, right? So when applying it, it's going to be y is an element. Then this is going to be negative, the absolute of 2, right? Plus q is 1, right? And this is going to be 2 plus 1. Let's simplify this. This is going to be what? This is going to be minus. This is going to be positive 2. So it's going to be just 2 plus 1. And this is going to be 2 plus 1, right? Then when you simplify this, this is going to be y is an element. Negative 2 plus 1 is going to give me negative 1. And 2 plus 1 is going to give me positive 3. And that is how you would find your what? This is how you find your range. Hope that makes sense, right? So now let's do 7.2, right? It says write down the what? Write down the period of G. So again, I'm going to give you the general form. I'm just going to copy this because I just need a couple of things from it. So I just need a couple of things, not the whole thing. So duplicate it, cut it. Okay. So we have the following, right? So I'm going to erase this formula because we're not looking for range. And I'm going to do the one for period, right? So for period is that if you're dealing with sine and cos, it's going to be that the period is equals to what? Is equals to 360 divided by the absolute of b, right? So we need b, and I already discussed what is absolute, right? So now we're going to just put this inside a block, right? And make it red, right? Now we're going to apply it. So we see the fact that we need the period. So the period is equals to 360 divided by the absolute of b. So we need b, right? So we need b. So going back, you see the fact that b is the one that is multiplying x, right? So we're going to go to g of x. So we see the fact that g of x is here. B is going to be this 2 in our case, right? So we see the fact that our b is 2. So therefore, applying here, it's going to be 360 divided by the absolute of 2, which is the same as 360 divided by 2, meaning our period is going to be 180 degrees. Hope that makes sense. So that's how you find the period for this question. So now we're going to move to 7.3. So they say for which which values of x between the interval, which is negative 180 till positive 180, will f be increasing. So I'm going to highlight f because I want to know what I'm dealing with. So we know the fact that f is this one, right? So this is going to be our f, right? So we want to check when this is increasing or decreasing, right? So to find something is increasing and decreasing, and this is from the concept of calculus, right? No, not calculus. Is that you see it mostly in calculus where they say find when f is increasing, f is decreasing, right? So the first thing is that we need to know what is the x value that we're dealing with, right? So this x value that we're dealing with is the turning point. So we're looking for the x coordinate of the turning point. And just to emphasize something, they can ask this question for any graph that has a turning point. So this type of question can always be asked if that graph that you're dealing with has a turning point. They can ask this question. So it's not an isolation of you're only going to see in calculus. Hope that makes sense, right? So now we see the fact that this is our turning point. Our point here is whatever y value, which we don't care, but we know the fact that the x value is 0, which is what we care about, right? Whatever y value, which is I'm going to call it TP. I don't care about the y value because our answer is in terms of x, right? So we know the fact that our graph is going to be divided from here. So I'm going to just divide it. It's going to be divided from here, right? So meaning we're going to have two portions. It's going to be, okay, it's going to be divided. The starting point of the first portion is going to be here, from negative 180, and it ends here at positive 180, right? So we're going to have two portions in our solution, meaning it's going to be 1, 2, right? Then how do we know that something is increasing or decreasing? You're going to write arrows on the graph that we highlighted, which is f of x, going from this direction, right? So following the graph going from left to right, right? You're going to write arrows following the graph. And we see the fact that when we draw arrows like this, see, follow the graph, drawing the arrows just like that. So we see the fact that in the first quadrant from negative 180 till 0, the arrows are going up. So meaning this section is considered as increasing. And the arrows from 0 till positive 180, the arrows are going down, meaning this section is considered as decreasing. Hope that makes sense. So our solution in our case is going to be what we're looking for, increasing, meaning it's going to be the first quadrant. So our solution for this question is going to be what? It's going to be x is an element from where? From negative 180 degrees till 0 degrees. And that's our solution for this question. Hope that makes sense. So now we're going to do 7.4. So it says use the graphs to determine the values of x for the interval from negative 180 till positive 180. And the first one, we're looking for g of x. So we're looking for g of x multiplied by g prime of x is less than 0. So let's understand what does this mean, right? It means when I'm multiplying g of x multiplied by f prime of x, I need to get a negative. And when can this happen? It happens in two cases, right? It happens at case 1, so I'm going to call this case 1, right? So case 1 is when if g of x is positive, right, then g prime of x, it needs to be negative, right? Because when we multiply them together, we're going to get a negative, right? Or case 2, if g of x is negative and and f prime of x is positive, I know when you multiply them together, it's going to be a negative. You're going to get a negative. So that's our two cases, right? So I'm going to color coordinate everything. So meaning, let me go back to black with this one. I'm going to color coordinate it. So I'm going to call the one that is positive green, right? Because I'm going to use it in the graph. So it's going to be the green one, right? And the one that is negative, I'm going to make it red. And everything's going to make sense, right? So now, understanding that, we need to understand the next portion, right? Is that what do we mean when we say maybe g of x is negative and it's positive, right? What does it mean, right? So when, or what does it mean for g of x to be negative and positive, right? So I'm going to say for g of x to be negative, or positive. When does that happen, right? So it happens for the following, right? When g of x in this case, right, is negative. So for negative, it's negative when it's a negative y-axis, right? So when it's in the negative y-axis, then g of x is regarded as being negative, right? And it's positive on the positive y-axis. And just for it to visually make sense, right, I'm gonna basically mark those points, right? So when does that divide? And we need to know which x values we're going to use. And the reason why I'm saying the which x values we're going to use, because of, remember the fact that we're writing our answer in the x values. So the x values that we need, right, is the following. So we need the x values, because I'm going to be dividing the graph within those x values. That's why I'm writing them now, right? So the x values that we need when we're dealing with what you call this y-axis and what you call this the positive y-axis and negative y-axis, the x values is what? Is the x-intercept of g of x. So it's going to be the x-intercept of g of x. And if g of x has asymptote, is that also an asymptote? If it has asymptote, because some graph has asymptote, but in our case it doesn't have asymptote. So I'm gonna go back and first mark off all the x-intercept of g of x, right? So we see the fact that the x-intercept of g of x is here, it's here, it's here, it's here, and it's here, right? And we know the fact that since this is divided by what? This is the period is divided by 2. So meaning each value here is going to be divided by 2. So meaning this point here is negative 90 degrees, right? And this one is 0, and this is positive 90 degrees. And maybe let me just show you how we got there, right? Is that a normal graph? So let me just show you a normal, because this is, let me go back. This is a sine graph, right? So a normal sine graph is going to be like this. Let me just show you, right? A normal sine graph is that it goes from here, then like this, right? And this is going to be 0. Then this is going to be what? This is going to be 180. And this is going to be 360. That's a normal sine graph. But remember the fact that our sine is compressed, right? So meaning this is going to be divided by 2 and this is going to be divided by 2. So meaning now the new x-intercept, right, for the sine graph, this is going to be 90 and this is going to be 180. And that's what's happening here, right? Do you see that's what's happening here? Hope that makes sense, right? Hope I didn't confuse you. So now we have established the x-intercepts, right? So with establishing the x-intercept, what I like doing is putting border lines, right? So I'm going to just put lines going up, dividing those portion, right? Because it's going to be dividing how we read our solution. So it also goes through here, right? Then this is going to be this one. Then it's going to be this one again. And finally, it's going to be this one, right? Then now, remember the fact that I said the fact that for negative, we're looking for when the graph is in the negative, our g of x, very important. We're just dealing with g of x, right? When it's negative, when our g of x is in the negative portion. So negative is the red one, right? So do you see the fact that our g of x is negative here? Just g of x, right? And it's also negative here, right? Hope that makes sense. Then it's positive where on the, when it's on the positive y-axis. So it's going to be positive here. And also it's going to be positive here. Hope that makes sense, right? So we dealt with when does g of x become negative and when does it become positive. And we also determine the x value for it, right? So now for g prime of, for f prime of x to be negative or positive, when does that happen, right? Is that for f prime, right? F prime to be negative. So let me just do this. So for f prime to be negative, that means the fact that f of x is increasing. So f of x is increasing. That's what it means for for f prime to be negative, is that means that f of x is decreasing, because we're looking at the first derivative. Hope that makes sense, right? Then for it to be positive, that means that f of x is increasing, right? So that's what it means to be negative, and that's what it means to be positive. So meaning when it's increasing, right, we know the fact that we're going to mark it in green because that represents positive, right? And when is when it's decreasing, we're gonna mark it in red because that means it's decreasing. It means, in our case, it means the fact that is the negative section, right? So that because of when we do the multiplication, we need to basically get a negative. Hope I haven't confused everyone and that makes sense, right? So now going up, right, is that we already established in this graph, right, what is increasing and decreasing. We know that this portion here, right, so we know that this portion here, right, it's going to be our increasing. And we know that this portion here is going to be our decreasing. And just one more thing I forgot is that, remember the fact that our x values for increasing and decreasing is what? Is our x coordinate of the turning point, right? So we know the fact that the x value is the x coordinate of the turning point for f of x, right? Turning point. So the nice thing, and meaning in our case, this is the line. So it's the line is going to be at 0 because that's where our f of x is. That is where our f of x, the x coordinate of the turning point is for f of x. Hope that makes sense, right? We have established that this side is increasing, so I'm gonna mark it in green. This side is increasing, right, and the other side is decreasing. Go back. So this side is decreasing. So now let me go back. Let me just put it properly like this, right? So now remember the fact that we're looking for when a green and a red, right? Because we know the fact that when green and red multiply, it's going to give us a negative. That's what we're looking for, right? So now, just to know where our solution lies, I'm going to mark them. This is going to be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Then we're going to start asking ourselves, in quadrant 1, we're looking for a green and red. We see the fact that we have both greens, meaning that they both what? They both increase, they both positive, and a positive gives you a positive. So this is not part of our solution. Then we see the fact that in quadrant 2, we have a green and we have a red. Then we know the fact that green is positive, red is negative. So meaning when we multiply to them together, we're going to get a negative, and that's part of our solution. And we see at quadrant 3, we have a red and a green, right? Meaning when we multiply them together, we're going to get a negative. And lastly, at quadrant 4, we see the fact that it's what? We see the fact that our answer is what? It's both red, meaning it's a negative and a negative, which is going to give me a positive. So this is not part of our solution. So our answer for this question, right, is going to be what? Our answer is going to be that x is between where? X is going to be between negative 90 till 0. So it's going to be negative 90 till 0, right? Or remember the fact that it's quadrant 2 and quadrant 3 is from 0 till 90. So it's going to be from 0 till 90. So it's going to be 0 till 90. And that's your solution for this question. So now we're going to solve 7.4.2. Remember the fact that when we start this question, they said, right, with the use of the what? With the use of the diagrams, right? We need to use the graphs. So with that being in mind, is that they tell us the fact that we need to solve the values of x for cos x is less than and equals to negative a half. So if we use in the graph, we see the fact that between the two graphs, right? So let me go back, is that I need to take my cos, the function that is cos, right? Take that, maybe our answers related to that if we need to use the function, right? We see the fact that f of x, and you'll see why I'm saying this. We see the fact that f of x, right? We see the fact that f of x is equals to what? So we see the fact that f of x is basically equals to 2 cos x, right, plus 1. So now let's basically solve everything where the other side is basically equals to 0, right? So taking this is that I'm gonna just put this inside a box, right? Just the green or red box, right? So I'm gonna put that, right? Let me see the fact that can I make the other side equals to 0, meaning moving everything one side. So the first thing is that I'm gonna divide both sides by what you call since it's division. I'm gonna multiply this by 2, so it's gonna be 2 cos x is less than and equals to negative 1, right? So I'm gonna take the negative 1 to the other side, so it's gonna be 2 cos x plus 1 is less than and equals to 0, right? What do I see? I see the fact that this is the same as this, meaning I can replace this by f of x, right? So this is the same as finding f of x, right, is what? Is less than and equals to 0, right? So that's what I'm finding. So what I'm going to do is that now I'm going to use my graph to solve for this, right? So now, using my graph, let's understand what does it mean when we're saying f of x is less than and equals to 0. Is that we're looking for what? We're looking for when f of x is negative, right? So meaning we're looking for the y-axis, right? So we're looking for when the y-axis, right? So we're looking for the y-axis when they negative. When they negative. So we're going to highlight that portion, right? Then what is the x value that we're dealing with? So the x values that our answer needs to be in terms of is going to be the x-intercepts. So that's what we're doing, right? So that's what we're looking for. So now using the graph, I'm going to just highlight the negative. I'm going to highlight the situation. What does this mean? Then I'm going to mark the x-intercept. Hope that makes sense. Okay, so the first thing first is that we need to mark off what is negative when y-x is negative. This is going to be the portion. So it's just going to be the bottom part. So I'm just going to highlight it and go back. Just want it big because I just wanted. So this means negative. Go down. So this is negative y-x, so all the negative part. So the negative y-x, this is, remember the fact that this is negative y-x and this is positive. So I'm marking everything that's down, which means negative y-x. So that's what it means, right? So remember the fact that we're looking for when f of x is negative from 0 going down, right? Hope I haven't confused anyone so far. So now our answers in terms of x-intercepts, right? So x-intercept for f of x is going to be this point here. So it's going to be this point here and also this point here, right? So that's our x-intercept. So I'm going to just put borders. So we know the fact that it starts here. Then it's here, right? Then it's here. Then our boundary, which is negative 180, so it's here. Yes, right? So we have how many? We have 1 between our boundary and our first x-intercept. We have 2, which is this whole point, right, from our x-intercept till our next x-intercept, and lastly 3, right? So looking at this, we see the fact that we do not have our x-intercept. We kind of need to solve for our x-intercept. So let's do that, right? So we need to solve for x-intercept. So solving, finding the x-intercept, right? So we know the fact that for x-intercept is that we need to let y equals to 0, right? So we know the fact that f of x in our case is equals to cos, it's going to be what? 2 cos x, right? 2 cos x, right, plus 1. So this is going to be 0 is equals to 2 cos x plus 1. Take the 1 to the other side. So it's going to be minus 1 is equals to 2 cos x, right? Divide both sides by 2, so it's going to be negative 1 over 2 is equals to cos x, right? Since we're dealing with trig, is that we're finding basically using like the general solution. So this, we need to find our reference angle. So we see that with our reference angle, we have the following, is that it's going to be arc of this, right? Then positive of this. So it's going to be arc cos, right, of a half, right? This is going to give us 60 degrees. Low-key, we have solved this one, and I'm going to go up and just show you where we did it. So let me just go up so that we can, where is it? Yes. We know the fact that it's going to be in the second and third quadrant where our cos is negative. Do you see the fact that we solved exactly, but here it was like 3x, right? So what I'm going to do is that I'm just going to copy and paste this because I just need this section, right? Duplicate, cut. I'm not going to cut corners so that you guys can see it. So we know the fact that our reference angle is what? Is 60, right? So let me just erase this. Okay. So we know the fact that now going back where our solution lies in the second and fourth quadrant because that's where our cos is negative. Do you see the fact that our cos is negative, right? So we know the fact that our solution lies between the two. So it's going to be what? It's going to be, our answer is going to be what? It's going to be this one. So it's going to be the angle. So in our case, our angle is just x. So it's going to be x. So let me just do this. This is the second quadrant, right? So we know the fact that it's going to be x is equals to 180 minus what? Minus 60, right? So when we say 180 minus 60, therefore x is equals to 120 degrees. Then for our third quadrant, so this is going to be all our third quadrant, it's going to be 180 plus, right? So it's going to be x is equals to 180 plus what? Plus 60, which is x is going to be equals to 240 degrees. But we see the fact that 240 is not a solution because of our answer. Our graph is between what? Is between negative 180 and positive 180. So this value here, meaning between the two, needs to be what? Needs to be 120. So meaning this, if it's 120, then this one is negative 120. Hope that makes sense, right? So now we have our x, our x-intercepts, right? So now we're gonna ask ourselves where, and now I'm gonna highlight the graph f of x so that everything makes sense, right? So our graph f of x is gonna be, go back, just want it small, yes. So our graph f of x is gonna be the green one. So we have everything. We have our x-intercept, and also what does it mean to be f of x, f of x less than and equals to 0, right? So now our question is, in each quadrant, we're going to ask our question, is our green graph in the highlighted yellow part? If yes, then that is part of our solution. If no, that's not part of the solution. So for quadrant 1, is our green graph, right, in the yellow highlighted section? We see the fact that our answer is yes. So from quadrant 2, we ask ourselves, is our green graph in the highlighted yellow part? No, it's not, right? Then lastly, in option 3, is our green graph in the highlighted yellow part? Yes. So our answer is between negative 180, right, till positive negative, what you call this? Our answer is between negative 180 till negative 120, or from positive 120 till positive 180. Hope that makes sense, right? So now our solution is going to be x. X is an element from negative 180. And I'm putting a square bracket, right? Because the question is less than and equals to. Hope that makes sense. So it's going to be from till or positive 120 till positive 180. And that's going to be your solution for this question. Hope that made sense. So now we're going to do 7.5. So it says the graph g of x is shifted 45 degrees to the right, right? Meaning if it shifted to the right means what? So let me just show you the right. So if this is right and this is 0, so to the right is in the positive section and this is negative. And since it's affecting x because it's moving on this line, so left or right, is that if it's shift to the right, you would expect to add plus 40, but you always do the opposite, like the opposite. Meaning if we moving to the right, since it's positive, when we put it back into the bracket, this needs to be negative. So this is going to be minus 45 inside our function, inside our formula. Hope that makes sense, right? So they tell us the fact that the graph g of x shifted to the right, and we need to obtain the new function h and determine the new equation in its simplest form. So we see the fact that we have g of x, right? And g of x is equals to sine 2x, right? So that's what we have. So our new function, which is h of x, right, is equals to sine, then 2, then remember the fact that it's going to be x, what? X minus what? X minus 45, right? So x minus 45 degrees. Then remember what? What did they say to us? They said the fact that we need to simplify it. So let's simplify it. So it's going to be h of x is equals to sine. We're going to distribute the 2. So we're going to have 2x, then 2 multiplied by 45. It's going to give me minus 90 degrees. So we see something. We see the fact that we have a reduction, right? We have a reduction, but with reduction is that this angle here, the 90, 180, needs to always be on the other side, right? So it needs to always be on the other side. So now let's clean that up. So I'm going to say h of x is equals to what? To sine. Then this is going to be negative 90 degrees plus 2x. We want to get rid of this negative because this number should never be negative, right? So it's going to be before we apply it to the reduction. So there's going to be h of x is equals to sine. Then we're going to take out the negative. So it's going to be minus. This negative becomes a positive becomes a negative. So it's going to be positive 90 degrees. And this is going to be minus 2x and close, right? So this, I'm going to take it as an angle. I'm just going to highlight it, right? I'm going to take it as an angle. So, yes. So this, I'm going to, go back. I need my pen. Okay. I need my highlighter. Yes. This, I'm going to take it as a whole angle. The whole green part that I highlighted, I'm going to take it as an angle. If that's the case, I'm going to apply this rule. Where is it? Okay. Let me just write it down, right? So applying this rule, which is going to be sine of a negative. So of a negative angle is going to give me what? It's going to give me negative sine, right? So that's what I'm going to do. So it's going to be negative sine. So this x is basically what? It's basically my whole angle. So let me just call it theta, not to confuse you guys. So theta. So this theta, right, is the same as my entire angle. Hope I'm making sense. So I'm matching them up, right? So this is going to give me what? This is the same as h of x is equals to minus sine. And this is going to be 90 minus 2x, right? So that is that, right? So now this is reduction, right? So if this is reduction, and I'm just going to go back up and go find my reduction table and all that goody things. So this one, duplicate, cut. Okay. Let's go up. Yes. So put it here, right? So using reduction, I'm just going to erase this one. Right? We're looking for 90 minus 2x. Let's go highlight it. I'm going to highlight it with a different color, guys. 1990 minus. So this is going to be this one, right? We see the fact that it's going to be positive. So this, yes, so it's going to be this one, right? So we see the fact that that is going to be now h of x is equals to minus what? Minus cos 2x. And that's going to be your final answer. So your final answer is that h of x is equals to cos 2x. Hope that made sense. So now let's do question 8. It says in the diagram ABC lies on the horizontal plane, right? And so meaning ABC is this portion that is in gray, right? Lies on the horizontal plane. And they tell us the fact that AB is equals to AC, right? Meaning AB is equals to AC. If our opposite lines are equal, so meaning the fact that this is also X, so this part is also X, right? The angle is also X. And they tell us the fact that D is directly above A. So as we can see it, such that what you call this 280. So 280. So 280, right, is equals to BC. So let's sort that out. So we see the fact that 280. So they tell us the fact that 280 is equals to BC, right? And they tell us the fact that AD is equals to 2, it's equals to P. So meaning that 2P is equals to BC. So we know the fact that this BC, which is here at the bottom, is equals to 2P, right? And they tell us the fact that angle ABC is equals to C, and angle DBA is equals to Y. So it's this one, right? So the first one, it says determine the length of AP. So they want us to basically determine the length of AP. Let me just find it, right? I'm going to do it in red. So they want the length of AB. So it's this one, right? Right, but they want our answer to be in terms of P and Y, right? So where does that lie? It lies on this triangle. Do you see that? It lies on this triangle. So we see that this triangle is what? It's a 90, which is a right angle triangle. So what does that mean? The fact that we can use trig ratio, right? So we see the fact that to get that we can use trig ratios, meaning we know the fact that opposite, which is I'm gonna have the angle of whatever, then this is going to be opposite over what? Opposite over the side that I want. So with opposite, I get to get this P and this angle, whatever trig ratio. So opposite over adjacent is 10, right? So if I say 10, 10 of the angle, and our angle is Y, is equals to opposite, which is P divided by the side that we want, which is AB. So now let's make AB the subject. So it's going to be AB multiplied by 10Y is equals to P. So therefore AB is equals to P divided by 10Y. So this side here is P divided by 10Y, and also the side is P divided by 10Y. So now we're going to move to the next question. It says we need to show that cos x is equals to 10x, right? So what do we see? We see the fact that we have 10x here, right? So we have that. And where is x, right? We see the fact that our x is here, right? So is that, what can we use is that we can find also the angle of, okay, cool. Before we go there, is that we can use sine rule, right? So meaning it's going to be the sine opposite its side, right? Then sine of this angle opposite to the side. But we cannot use this 2 because of it's basically the same thing. So meaning the triangle 1, the triangle that we're focusing on is this triangle, the gray one, right? Since we're focusing on the gray one, is that we cannot use both the sides, right? As I said, the fact that they're practically the same thing. So it's not going to render us whatever we want, which is cos x is equals to 10y, right? When you try that one. But we can find this angle A and basically use this relationship. We can use the fact that this one, this angle opposite one side, then this angle opposite this. And we can find this A using the sum of angles in a triangle. So let's do that first, right? Finding A, right? So finding angle angle BAC, right? So we know the fact that angle BAC angle BAC. What's happening? BAC, right? Plus this angle, which is angle ABC, plus this angle, which is angle ACB, right, is equals to 180 degrees. And this is sum of angles in a triangle. Sum of angles in triangle, right? We know that, right? So we also know the fact that these two are both equals to x. So the one that we want, which is BAC plus this is x plus another x, is equals to 180 degrees, right? So this is the same as BAC plus 2x is equals to 180 degrees. So therefore BAC is equals to 180 degrees minus 2x, right? So this is what? This is 180 minus 2x, right? So now we have that situation sorted. So meaning I can use what? I can use the sine rule, meaning it's going to be, I'm just going to mark it. It's going to be this one, or let me just do it with the highlighter, right? Yes, it's with the small one. It's going to be this angle and its corresponding side, right? Then it's going to be this angle with this corresponding side. So that's what we're going to be doing, right? So with that said, that's what I'm going to be applying, right? So I'm using sine rule, right? So using sine rule, I'm going to say sine, and this is going to be the angle, what? So it's going to be BAC, right? Divided by its side, right? Which is going to be what? Which is going to be BC. So it's going to be BC, right? It's equals to sine. So I'm going to use this one, right? Which is going to be ABC. So it's going to be ABC divided by what? What is its side? It's AC. So it's going to be AC, right? So now let's substitute. We know the fact that this is going to be sine, and this is going to be what? 180 minus 2x. Then the length of that side is 2p, right? From the diagram. Then this is going to be equals to what? It's going to be sine x. Then its side is going to be p divided by 10. So it's going to be p divided by 10y, right? Then we're going to cross multiply. So when we cross multiply, we're going to have p, right, divided by 10y, sorry, multiplied by sine 180 minus 2x, right? It's equals to 2p, right? And this is going to be sine x, right? So we're going to have that, right? So now with that is that we're going to just multiply the entire thing. So first, let's apply reduction to here, right? So we're going to apply reduction. So when we apply reduction, I'm just going to go back and just going to show you. Let me just copy and paste this. Duplicate, cut. Okay, so put it here. Okay, so I'm going to just erase this one, right? We're looking for 180 minus. So 180 minus. So what is 180 minus? So we know the fact that it's red to red. So it's going to be 180 minus. Or what's 180 minus? Sine 180. So it's going to be this one. So it's going to give us positive, right? So this is going to be the same as p divided by 10 y, right? Multiply by what? Multiply by sine 2x is equals to what? Is equals to 2p multiplied by sine x, right? So we have that, right? So with that is that what I'm going to do is that we need this. Remember the fact that we need this 10x. So I'm going to multiply it this side, right? So it's going to be p multiplied by sine 2x, right? And this is going to be equals to 2p. Then this is going to be sine x. Then this is going to be 10y, right? So we have 10y on the other side. Now we see the fact that this is an identity, right? We see the fact that this is an identity. We see the fact that this is an identity, right? So applying that identity, so I'm going to say applying applying identity. So the identity is sine 2x is equals to 2, right? It's going to be equals to 2 sine x cos x, right? So I'm going to highlight or put this into a box, applying this identity, and I'm going to do it in yellow because that's how I highlighted it, right? So applying that identity, we know the fact that p is going to be multiplied by now 2 sine x, right, multiplied by cos x is equals to 2p, right? And it's going to be sine x, then multiplied by 10y, right? So going back is that we're looking to prove what? We're looking to prove cos x is equals to 10x, right? So now when we do this is that, do you see the fact that I can highlight what we want? We want this and we want this. That's what we want, right? That's what we want. Meaning I can divide both sides by what we do not want. So what do we do not want? We do not want, so let me just rewrite it and divide it. So it's going to be 2. So 2, let's put the 2 here. Then this is going to be sine x multiplied by cos x is equals to 2p. Then it's going to be sine x. Then it's going to be cos y, right? Divide both sides by what we do not want, the part that I did not highlight in green. So which is going to be 2p sine x. And it's going to be 2p sine x. This and this are going to cancel each other. So therefore, you're going to have that cos x. So therefore, you're going to have that cos x is equals to 10y. So now doing 8.3, it says if x is equals to 60 degrees, calculate the size of y. The nice thing is that in the previous question, we already know that cos x is equals to 10y, right? So from there is that we're going to use that, right? So we're going to use from that. So we know the fact that cos x is equals to 10y. So we're going to substitute 60 here. So cos 60 degrees is equals to 10y. So let's punch this into the calculator. We're going to find the fact that this is going to be a half is equals to 10y, right? So we're going to solve for y. So solving for y, so let me just write it from this side. So 10y is equals to a half. So it's going to be arc10. So it's going to be arc10 of a half, right? Therefore, y is equals to, when you punch this into the calculator, you're going to get it as 26.57 degrees. And that's how you would solve this question.
Okay, so now let's do question 9. So let's read the question. It says in the diagram triangle D. So we see the fact that they say triangle D, E, F, right, is drawn, as you can see. Then they tell us the fact that the line GH, so the line GH intersects, right, DF, so meaning it intersects this line and this line, right, at G and H respectfully, such that they tell us the fact that the line GH is parallel to the line DE, and also they gave us the fact that GH, so GH, so let me just take my pen. So they tell us the fact that GF, so which is this small line, is equals to 2, the ratio, and DG, which is going to be this one here, right, is equals to 5. So we know the fact that this is equals to 5, right? So that's the information that they gave us, right? So the first question, it says, write down with reason the value of HF, right, divided by the ratio of HF divided by EF, right? So what are we looking for? I'm going to highlight it. So we're looking for the following. We're looking for um, HF, so it's this line, right, the ratio of it, then divided by EH, so it's this one, right? We're looking for that. So since this is a triangle, right, and I'm just going to have small notes here. Since this we have a triangle, so we have a triangle, right, and the triangle has parallel lines, so as we can see, right, it has parallel lines, so like this, right? And it means the fact that the ratio here, so meaning this line, right, divided by this one is going to be equals to this one divided by this one. So for instance, this is A, B, C, and this is D, E, right? So that means the fact that AD, right, divided by what? By DB is equals to what? Is equals to AE, right, divided by what? Divided by EC. Or it can be like this, which is I'm going to write it in red. Okay, cool. So we can write it in red. So also I can say the fact that the small one, right, divided by this entire big one is the same as the small one divided by this big one, right? Meaning if I'm writing it down, it's the same as saying AD divided by what? Divided by AB, right? Is equals to AE divided by AC. Hope that makes sense, right? And vice versa. So this is the proportionality theorem, right? Because of we have parallel lines, which in our diagram that I just showed as an example is DE parallel to BC. So with that in mind, now let's answer this question, right? So they gave us what? They gave us DG divided by GF, right? So that's what they gave us. And now they want us to find what? They want us to find EF divided by by EH, right? So we see the fact that this, right? We see the fact that this divided by this is equals to what they want, which is this divided by this, right? So now let's do that. We know the fact that HF divided by EF, right? So HF, right, matches with what? So this one matches up with the small one, which is going to be GF, right? So it's going to be equals to GF. And this one, right, which is EH, matches up with this one, which is DG. So it's going to be DG, right? So we're saying the fact that this is equals to each other, and our reason is going to be what? The proportionality theorem, right? And always write your parallel lines because you're going to encounter a place where you have multiple parallel lines. So make sure the fact that you always do your parallel lines. And our parallel lines is that GH is parallel to what? To DE, right? So now we already know the fact that what you call this, that GF divided by DG is equals to 2 over 5. So we know the fact that therefore HE, so therefore HE divided by EF is equals to 2 over 5. And that's how you would answer this question. So now we're going to do 9.1.2. So the question says if EH, so we know the fact that EH goes from here till here, and they tell us the fact that that is 21 centimeters. So they tell us the fact that this is 21 centimeters, right? And they want us to calculate what? They wanted to calculate EH. So EH, I'm just going to do it in red because that's the one that we want. They want us to calculate this in centimeters, right? So now remember when I talked about the proportionality theorem, the red one. Let's focus on the red one. I said the fact that we can take the entire part divided by the small portion that we want, and it's going to be equals to the other side. We already know from here the fact that we have this, right? So meaning, do you see the fact that they gave me what? Because I need to use the 21 centimeters to calculate this one, right? I already know the fact that this whole thing matches up with this whole thing here, right? Which is going to be 5 plus 2. So meaning this whole thing, the ratio is 7. Then the one that we want is this one, right? The small portion matches up with the small portion. But the nice thing is that we already know the fact that the big one is 21. So with this 21, I can find the centimeters of this one. But first, we need to state the proportionality theorem, right? So we know the following, right? We know the fact that with the proportionality theorem, we know the fact that I'm going to just put in the numerator, the one that I want, right? Divided by what? Divided by the small portion, the bigger portion, which is right? Is equals to what? Is equals to what? Is equals to what matches up with the small portion. So we need to match this one first, right? So this one matches up with DG. So we know the fact that that's going to be DG, right? And we already know that DG is 5. So that's great, right? And that's going to be divided by what? Divided by the bigger portion, which is EF, which matches up with this one, which is going to be DF. So this is going to be DF, right? And that's going to be equals to what? That is going to be equals to 5 over Remember the fact that the whole part here is this 5 plus 2, so it's 7. So it's going to be over 7. And what's our reason? Again, like the first one is going to be the proportionality theorem. And we know that the parallel line, so it's going to be what? That GH is parallel to DE, right? So now we know the fact that H, right, is divided by F is basically equals to 5 over 7, right? Remember the fact that 5 over 7 is the ratio, is not the actual units, right? It's not the distance on how much it is, right? So, but we already given that EF is equals to 21, so let's substitute so we can calculate EH. So we know the fact that EH, right, we know that EF is equals to 21 centimeters, right? And this is equals to the ratio, right? So now we're going to cross multiply. So we know the fact that's going to be 7 EH is equals to 5 multiplied by 21 centimeter, right? So this is going to be EH is equals to 5 multiplied by 21 centimeters divided by what? Divided by 7, right? And therefore, let me just go to the next page. So therefore, we know the fact that H is equals to, punch this into the calculator, is going to be equals to 15 centimeters. And that's how you would solve this question. So now we're going to move to the next question, which is 9.1.3. It says write down a triangle which is similar to FGH. So let's highlight the triangle that's in question that we need to make sure the fact that it's similar. So we know the fact that FGH is the small triangle, right? So we need to find another triangle that's similar to that, right? So let me just do this properly, right? So that is the triangle, right? That we need to measure it. Then we see the fact that this, do you see the fact that this is going to be common? So the bigger triangle. So let me just highlight another triangle that's similar to it. And honestly speaking, this is the case always. If you have a triangle and it has like a line in between and there's parallel lines, always the small triangle is always similar to the bigger triangle. So the bigger triangle in question is this one. So this is the bigger triangle in question, right? So always, this is an always case. If you have a big triangle and it's divided by a line and these parallel lines, always is that the smaller triangle is always going to be similar to the bigger one. So in this case is that our big triangle is similar to the small triangle, so meaning the other triangle that's in question is going to be what? It's going to be that triangle of the small one. So we know the fact that triangle FGH is similar, right? So 3 lines, it's similar to the big one. So the thing is, when writing the two triangles like the alphabet, is that you need to match it exactly with the angles that it's similar to it, right? So meaning you need to map it up exactly how. Do you see the fact that if you're saying FGH, right? So meaning it's going to be, let me just explain. This is FGH, right? So meaning for the yellow one, I need to match up with the angles that are equals to it, right? So in our case, it's going to be like that triangle F. So F and F is the same angle, right? So now G, I need to know which one is G, right? Which one G is equals to. So G, right? So we see the fact that since it's parallel lines, you see the fact that this is parallel lines, it creates an F, right? So meaning this angle and this angles are equals to each other. So meaning for the big triangle, meaning this and this are equals, right? So I can put ticks there. So we know the fact that these two are equal. And also, even this side is that it creates an F. Do you see that? Meaning this and this are equal. So I'm going to put a cross like this, right? So now we know that G matches up with D. So meaning for the bigger triangle, sorry, for the bigger triangle is going to be D. And we know that H matches up with E. So it's going to be E. So that is the next triangle. So we know the fact that our triangle that was in question, which is highlighted in red, is similar to the triangle FTE. Always make sure the fact that the angles matches up. And the reason for that is that because if we matched up the angles to each other, so reason is going to be angle, angle, angle. And that's how you would answer this question. Hope that makes sense. So now we're going to do question 9.1.4. It says, hence calculate the value of GH divided by DE. So let's highlight what they're looking for, right? So we know the fact that DH, we're highlighting it. So DH is this one, right? And divided by dE. So it's this one, right? So we need to calculate the value of that, right? But looking at it is that we cannot use parallel lines because of the only, going back, the only possible values that we can get in the relationship of the proportionality theorem is from this one, right? Anything besides that is not going to give us our answer, meaning this cannot be equals to this according to the proportionality theorem. But that's completely fine because of, remember in the previous question, which is 9.1.3, we proved the fact that this two triangles, the red one and um the red one and the yellow one are similar, right? So we can use similarity now to basically prove the fact that the line GH is equals divided by DG, we can find their values. So what I like to do with triangles is that I like pulling them out, right? So I'm going to pull them out because of it makes it very easy to work with, right? So I'm going to have the small triangle, which is the yellow one. So let me just do that. So this is the red one, right, from our previous, and I'm going to pull out the big one, which is going to be the yellow one, right? So that it matches up with everything that we have done, right? So we know the fact that the red one is going to be what? Is F. So we know the fact that, let me just delete this. So we know the fact that this is F and this is G and this is H, right? So we know the fact that F matches up with another F for the yellow one, right? And G matches up with D, so this G. So I'm going to put ticks, right? Then lastly, we know the fact that H matches up with E. So it's going to be E, right? X and X, right? So what do they want? I'm going to highlight what they want here on the triangle. So we're looking for what? For GH, which is the bottom part. So we know the fact that we have highlighted GH. So now let's highlight D, E, which is what they want, right? So now we already know from the previous, remember the fact that when we're calculating the ratio, right? Said like, let's match it up with what we know, the ratio that we know, right? So let's go back up, right? So we're gonna go back up. We know the fact that the from the small triangle, right? From the small triangle, which is this one, right? We have that GF is equals to 2. So let's look at for GF right here and let's equate it to 2. So we know that the GF, right? So which is this side, right, is equals to 2, right? So that's sorted, right? So we know also from that ratio, we know the fact that the bigger side, right, which is this one, right, is equals to 7, right? So we know the fact that DF from the big triangle, so DF from the big triangle is equals to what? Is equals to 7. So we know the fact that DF is equals to 7, right? So we know that, right? So we already know the fact that the ratios, we know the fact that it's 2 and 7. So what we need to do is that we need to match it up, right? So we know the fact that this, right? We know the fact that these two are related. So we know that these two are related. Then from, since we're going to start from the small triangle, so we know the fact that that ratio is equals to this divided by this because that's what we given, right? So what we can do is the following, is that we know the fact that GH, right, divided by D E is equals to GH in the small triangle, the one that we given the fact that FG is 2, right? So I'm going to use FG, right, divided by, in the big triangle, what are we given? We given FD, so it's equals to FD, right? So we can do that if we find similarity triangles. Maybe I should go a little bit, maybe I should explain it. I'll explain it and erase it, right? So let me just find another color, right? So here is that what can I do is that I can find ratios of two sides, and the reason why I can do that is because of a similarity triangle. So for instance, and I'm just going to erase this, right? So I can find the fact that FG, right, divided by, maybe divided by F D is equals to any side, meaning I can say the fact that FH divided by who matches up with FH. So we know the fact that FH is this one, so meaning it's going to match up with this side, right? So because of both, you see the fact that the angles is a star and a dot, and here's star and a dot, so that they match it up. So the fact that it's going to be equals to FE. Hope that makes sense, right? And the reason is going to be the fact that the triangles are similar. So that is the reason. Hope that makes sense, because we already proved here the fact that the triangle are similar. Hope that makes sense. And also I can do the same thing with another side, meaning another side is that the GH that they want, right, divided by the side that matches up exactly. Do you see the fact that this is a tick and a cross? So this side matches up exactly with this side because it's a tick and a cross, right? So meaning divided by the side that it matches up, which is going to be DE, right? Right? And now we can pick any side, right? So any side, but that side needs to match it up. So let's say we pick this, sorry, let's say we pick up this side again, and it's equals to another side that's like that. So it's going to be what? It's going to be F H. And remember the fact that if we're going to start in the smaller triangle, you need to match it up the on the other side, right? After the equal side, you need to also match it up with the smaller triangle. Hope that makes sense, right? So this is going to be what? This is going to be FH is going to have to match up with this one, which is FE. FE. And again, it's going to be similar triangle. Hope that makes sense. So that's what you can do with similar triangle. So taking that idea, that's what I did here, right? So that's what I did here, is that I knew the fact that these two ratios, right, which is what we want, I need to map it up with any side. Any two side, it could be this one or this one, right? But in our case, is that the one that has ratios is this. It has already numerical ratio. So I knew the fact that if I map it up with that, I'm gonna know what it is equals to. Hope that makes sense, right? So now let's write what is the reason to this one. We know the fact that this is because of what? Triangle. So triangle F. So let me just do this. So we know the fact that triangle FGH is similar to triangle FDE, right? Because we proved it in the previous one. So the nice thing is that we know the fact that GH divided by DE, we already know what FG is. FG is 2, and we already know what FD is, and FD is 7. So that is going to be our final answer. Hope that makes sense. Okay, so now we're going to do 9.2. So first, as I think if you've watched my Euclidean geometry videos, is that it's very important to first fill in the diagram. Then when we're done filling in the diagram, we can move to answering the question. So that's what I'm going to do. So I'm going to use different colors. So for the first one, I'm going to use an yellow highlighter, right? So it says in the diagram, POL is a diameter of the larger circle with center O, right? So we know the fact that this line is a diameter. And what do we know about diameter is that two properties that needs to come in mind is that angle at center twice the angle at circumference, and also angles of a semicircle. So we see the fact that we can have angles of a semicircle. You see the fact that that one we have. Then I'm just going to move to my yellow. So we know the fact that this is going to create a 90 degrees, right? So on the side, I'm going to say diameter. And this is for the larger circle, right? And we know the first thing is that going to be what? Is that angle what? I'm just going to name it, which is going to be in our case angle R. So it's going to be LRP, right? So it's going to be LRP is going to be equals to what? It's going to be equals to 90 degrees, and it's going to be angles in a semicircle. So I'm going to say semicircle, right? So that's my reason. So we know that. Then we check the fact that can we have angle at center twice the angle at circumference. So we're going to test it out. So I'm just going to go back. Yes. So I'm going to go back and first erase this, right? And test angle at center twice the angle at circumference, right? So we know the fact that this is going to be what? We need what? We need angle. So we need the angle at center, which is we have, right? Then we need the 2 points at the circumference, right? So we see the fact that L is at the circumference, but M is not in the circumference. It's outside the bigger circle. Do you see that? It's M, it's outside the bigger circle. And I'm just going to emphasize the bigger circle like this, right? Or let me just do that. Let me just, yeah. So we see the fact that this is outside the bigger circle, right? So here, from here, we can't do angle at center, which is going to be angle at center, right? And angle circumference because this one is outside. Hope that makes sense, right? So we see another point that is in the circumference of the bigger circle is this point here, point R, right? So let me just do that. We see that point R is within the circumference, right? But we see the fact that if we do angle at center towards the angular circumference, let's test it out, is that this line can go to the center, but this R can't go to the center. Do you see that? It doesn't go to the center, so we can't have angle at center twice the angular circumference. Hope that makes sense, right? So that one dies automatically, right? So we know the fact that the only property for the large diameter is going to be what? Is the 90 degrees. Hope that makes sense, right? So now I'm going to change my color, right? Going to orange. And for orange, I'm going to just read the following information. They tell me that TMR, so TMR is the diameter to the smaller circle with the center M. So this one is the diameter to the smaller circle, right? And we see the fact that we can create also a 90 degrees because of, do you see the fact that the points here are on the circumference and creating a triangle, and this line passes and this line passes through the diameter. Hope that makes sense, right? So we know the fact that this is also 90 degrees. So this is 90 degrees. So I'm going to still keep it at yellow because of they all share the same, what you're going to think, all share the same angle, which is 90 degrees, so that we the whole point is to match up equal angles, and we're gonna basically arrange them with the same color. Hope that makes sense, right? So I'm gonna first change my highlighter, my color here to diameter, because for the smaller circle is orange, and I'm gonna say this is for the smaller circle, right? And I'm gonna go back to yellow because we know the fact that angle L2 is equals to what? To 90 degrees, and reason is gonna be semicircle. Hope that makes sense, right? So now we're gonna check angle at center twice the angular circumference, right? So what I'm gonna do is that I'm gonna erase this so we can test for that, right? So angle at center twice the angular circumference. So I'm gonna just take my highlighter. Is that, remember the fact that we have center, right? So we have center, then we need 2 points at the circumference, right? So starting from here, we see the fact that we have this point L, it's at the small circle circumference, and also this one, right? Let's check, can we do angle at center twice the angular circumference? We see the fact that T can go to the center, but L cannot go to the center. Do you know? Do you see the fact that it only goes to the circumference? So those 2 points don't match up with angle at center twice the angle circumference. So now I'm going to delete that. And we're going to check for what? For another point on the circumference, which the 2 points, let me just take my highlighter. It's going to be N. N is on the smaller circle circumference, and also R, right? And we see the fact that R can go to M, right? And N can also go to what? To N. So we have the angle going to the center. Now we need both M and R leading us to the circumference. We see the fact that R can go to what? To L, and also R can go to L. So we see the fact that this angle here, which I'm going to make it in a different color, this angle here is equals to 2 times this angle, right? So we see the fact that what? So we see the fact that angle M1 is equals to 2 times angle L3, right? And is angle center circumference. I'm going to call it center, center equals 2 times circumference, right? So that's what we know. So we know the fact that this one is equals to 2 times angular circumference. So I'm going to make it into that. Hope that makes sense, right? So now we have everything that is related to what? That is related to the diameter and the center. Hope that makes sense. So now we're going to move on and read the following, the information that they gave us. They tell us the two circle intersect at L and R. That doesn't give us anything, but this part gives us something, right? They tell us TLK is a tangent to the smaller circle at L, right? So now let's find that another color. So I'm going to use color what? I'm going to use color green, right? So they tell me the fact that T, so which is called PLK, right? Creates what? Creates a tangent, right, to the smaller circle. So first is that I can use 10 chord. Do you see the fact that I can use 10 chord? So I'm going to draw a triangle, right? And first what we're going to do is that I'm going to delete this. I'm going to just focus on the first portion of the tangent, right? Because the tangent is like extended throughout. So I'm going to focus on the LK tangent part, right? So I'm going to say go back to green. So I know the fact that I'm going to say tangent LK, right? So focusing on that, right, is that I see, so from the following, I see the following. I see the fact that this angle here, right, is equals to this angle, and the reason for that is 10 chord. So do you see, how do we know? Is that when we do this, the angle that's between the tangent and the chord, right, that angle is equals to opposite this angle when you create like a triangle. So this one, right? So that's 10 chord. So we know the fact that what angle L1 is equals to angle R1, right? And the reason for that is 10 chord. So we sorted that out. So as I said, the fact that we extended only, we just focused on the LK part of the tangent. So now I'm going to do is that I'm going to focus on the LP tangent part, right? And from there is that I'm going to see the fact that this angle here, so this angle here, the angle that's between the tangent and the chord, which is going to be this angle. So I'm just going to change it into a different color. So I'm going to make it light green, right? So I can see the fact that this angle here, do you see this one, right, is equals to the opposite one, which is going to be this one, right? So I'm just going to do double lines so that we don't get confused, right? So that we know it's different angles, right? So we see the fact that angle, and I'm going to name it, which is going to be angle PLR. So it's going to be PL, so this angle that we want, R, right, is equals to the angle T. So let's do that. So we know the fact that angle PL, right, R is equals to angle T, right? And the reason for this is going to be what? It's going to be 10 chord theorem. So this is going to be 10 chord theorem. Hope that makes sense, right? So that's what we have, right? So now we have sorted out the tangent for the smaller circle, right? So let me just erase this highlighter because I want to focus on the other one, right? So now let's continue reading the question. It says, right, so I'm going to take a different highlighter, right? So my highlighter will be blue. It says okay, cool. So it says the two circle intersects at L and R, and they wait, sorry about that, is that I see the fact that for the green one it deleted it. So yes, right? So we see the fact that they continue, they tell us the fact that TR is a tangent to the larger circle, right, at R, right? So let's find TR. So we see the fact that R is here, then where is T? So T is this one. So this is a tangent to the larger circle, right? So we see the chord that's between the tangent and the tangent and the chord is this one, and we see the fact that this creates a triangle on the big circle. Do you see that? Right? So that means that this small green, do you see the fact that this green angle here, this green angle R1 is also equals to angle P, and that's 10 chord, right? So I'm just going to change my color now into blue, saying the fact that we're dealing with the tangent. So this is the tangent, this is the tangent, TR. So this is TR, right? And we see the fact that the angle that is matching it is what you call this. It's also green, right? Because we see the fact that angle R1 is equals to angle P, right? And the reason is 10 chord, right? And here I want to fix the the LK. So I want to fix the entire tangent, saying the fact that the whole tangent, because I looked at both scenarios. So it was the tangent what of the line PLK. So it's PLK, right? So now we have everything that is related to the information, right? So now let's read more on it and see the fact that we have everything. So now the question continues and says the fact that OM intersects the smaller circle at N, and they tell us the fact that the straight lines LK, LT, LR, LN, PR are drawn. So nothing gives us any information. So now let's answer the first question. The first question says we need to prove giving reasons that LT is parallel to what? To PR. So now let's highlight what they want from us, and I'm always going to highlight using the red highlighter, right? So with that is that let's find LT. So LT is this line, right? Right, we need to prove that that line is parallel to which line? PR. So we need to prove that these two are basically parallel to each other. So we need to use the properties of what? The properties of parallel lines. We know the fact that if we have these two as being parallel lines, right? Is that what is the following? Is that we can use the Z, meaning alternating angles. So meaning the alternating angles is that if I put a line here, that means that I can prove that these two are equal, right? And if I can prove that the two are equal, therefore the lines are parallel. The nice thing is that you see the fact that L2 is 90 degrees and R2 is also 90 degrees. So we actually, from writing our information, we have proven the fact that they're parallel. So now let's state the fact that how are they equal, that both of them are equals to 90 degrees, and therefore since they both equals to 90 degrees, they equals to each other, therefore meaning the fact that they are what? They are what you call this, LT is parallel to PR, and the reason for that is alternating angles. Hope that makes sense, right? So let's do that, right? So the first one is going to be what? Let me go back to black. Is that we know the fact that angle L2, right? So we know the fact that angle L2 is equals to 90 degrees, right? And the reason why we know that is angles in the semicircle from our information, right? So we know the fact that that's going to be what? Angles in semicircle. So it's angles in semicircle, right? And we also know the fact that R2 is also equals to 90 degrees. Same reason, angles in semicircle, right? So therefore, we know the fact that angle L2 is equals to angle R2 because they both equals to 90 degrees. So therefore, we can conclude that LT is parallel to PR, is parallel to PR, and the reason for that is a Z, so meaning it's alternating angles. So it's going to be alternating angles, right, are equal. So we are done with answering this question. So now let's do 9.2.2. It says LOR is a cyclic quad. So let's basically join the circle quad that they're talking about, right? So I'm going to take this and I'm going to make it in red, right? So we see the fact that LO, so we know the fact that LO, so this line, right? Then it's going to be its LO, then is OR. So we see the fact that from OR to like this. So let me just do it properly. So it's going to be like this line going here, right? Then we see the fact that R, so it's going to be RM. So it's going to be this two here. Then finally this two, which is going to be LM, right? So we see the fact that they say that L is a cyclic quad if it's given what? If it's given that TR is parallel to what? To OM, right? So they also give us the fact that basically we're proving. Remember the fact that if we go up, it says prove giving reasons. So we need to prove the red one, the cyclic quad that are highlighted in red, right? It's a cyclic quad, but they give us extra information, which is L. So which is going to be LT, sorry. So it's going to be LT, so it's going to be LT. So we know the fact that L is here, LT is parallel to what? So we know, let me just do it with another color because I feel, okay, LT, which is the purple one, is parallel to OM. So it's parallel to this one, right? So we need to prove the fact that that is what? We need to prove the red one is a cyclic quad if we given that this is what this is, these two are parallel lines. Hope that makes sense, right? So from the parallel lines, let's put in the information that we need, right? We see the fact that from the parallel lines, if we draw a line going like this, we see the fact that this whole angle, what you call this L2, so I'm going to do it in purple. So adding more information, we know the fact that angle L2 is equals to what? So this angle here is equals to what? Is equals to this angle here. So that doesn't matter because they didn't name it. So I'm not going to use that because they didn't even name the angle that it's equals to, right? But we see the fact that we have an F, right? So if we have an F, so from here we have like an F like this. And with that F, we see the fact that L1, right? So we see the fact that with that F, we see the fact that L1 is equals to O1, which means the fact that this is also what? This is also green, right? So meaning this angle is also green from the parallel lines, right? So we see the fact that L1, right, is equals to angle O1, right? And the reason is corresponding angles, right? So we have that, right? Then from that is that when proving that something is a cyclic quad, is that we need to prove that right. We see the fact that we have a butterfly, right? And I'm going to just use red to show, to emphasize the butterfly. Do you see the fact that we have, I want to use red. So we see the fact that we have a butterfly, right? Meaning this angle here, we need to either prove the fact that this angle here is equals to this one, right? Or this angle here is equals to this one. What do we see? From me putting in the properties of a parallel lines, we see the fact that angle O1 and angle R1, they both equals to the green. So I'm going to use that to prove that this is actually a cyclic quad. Hope that makes sense, right? So we first going to go back to what we're going to, I'm going to use the parallel lines situation before we go to how R1 and L1 are equals to each other, right? So we know the fact that angle L1, right, is equals to what? Is equals to angle O1, right? And our reason was what? Our reason for that is that corresponding angles, right? So it's going to be corresponding angles, right? So it's corresponding angles. And I'm just going to put in the parallel lines. It's very important to put in parallel lines. Reason for that is that sometimes you'll be dealing in a question, you're dealing with multiple parallel lines. So it's very important to state which ones, right? So in our case, it's LT is parallel to OM. Hope that makes sense, right? So we know that, right? Then now I need to basically prove, remember the fact that this is O1, right? I need to prove the fact that how is R1 equals to this. So what is R1 equals to, right? I'm going to go back to our information. We know the fact that L1, right, is equals to R1, and our reason for that is 10 chord. Remember when we were doing the information, right? L1 is equals to R1, and that's 10 chord. So it's coming back. So we know the fact that L1 is equals to R1, and our reason is what? 10 chord theorem, right? So it's going to be 10 chord theorem. So what do we see? We see that both O1 and R1 are both equals to L1. So therefore, we see the fact that angle O1 is equals to angle R1, right? Because they both equals to what? They both equals to L1. So that is great because of that's what we wanted to prove. So therefore, I can conclude that LORM is a cyclic quad, right? So we can conclude that is a cyclic quad. And what is our reason? Remember the fact that our reason is the fact that it's angles in the same circle, right? Angles in the same segment. So we're going to say converge. Then we're going to write the fact that if we had to, like, let's say they told us the fact that it was angles in the same, like we already knew the fact that it's a cyclic quad. So our reason is going to be what? Angles, converge angles in the same segment, right? So, sorry, segment. Right? So that is going to be how you answer this question, right? So hope that makes sense on how you would answer and approach this question. So now what we're going to do is that we're going to do 9.2.3, which says the fact that we need to prove that Ln, so let's highlight that. So we need to prove that Ln, so Ln is going to be L and N is here. So this line here, right? We need to prove the fact that that line bisects the angle OLR, so this angle here. So what does that mean, right? It means the fact that we need to prove that angle L4 and angle L3 are basically what? Are basically equals to each other. So that's what we're trying to prove, right? So when a line bisects an angle, that means the fact that we need to prove that the angles that are between that bisection are equals to each other. So that is the goal, right? Okay, from there we see the following. We see the fact that M1 and L3 are basically equals to each other, and that is angles in a semicircle, right? What you call this angle, what you call this, that is basically angle at center twice the angle at circumference. Let me just go back because we already said that. Do you see the fact that we already said the fact that angle M1 is equals to angle 2 times angle L3, right? So we proved that, right? Then another thing is that looking at our question, right, is that do you see the fact that, and I'm just going to erase it, but I just want to extend this, right? Do you see the fact that this, we proved the fact that this whole thing is a cyclic quad, right? And since we proved that this is a cyclic quad in the previous question, is that we proved the fact that angle M1 is equals to angle, what you call this, angle what you call this, L4 and L3. So meaning the angle OL OLR, right? So we know the fact that that is going to be equals to each other. And the reason is that angles in the same segment, right? And that was proven the fact that that whole thing that I just highlighted is a cyclic quad in the previous question. So since we have both relationship, both equals to M, is that if we equate those results, is that we're going to get the fact that actually L3 and L4 are equals to each other. Hope that makes sense, right? So I'm going to start with the one that talks about the previous. So we know the fact that angle, so we know the fact that angle L4 plus angle L3, right, is equals to what? So it's the whole green part, right, is equals to angle M1, right? So we know the fact that this is equals to angle M1, and our reason for that is angles in the same segment. So it's going to be angles in the same segment, right? So we know that. But also we know the fact that angle, what you call this, angle M1, right, is equals to 2 times angle L3, right? And the reason for that is angle at center twice the angle at circumference, right? So it's angle at center, right? Angles at center equals to what? Equals to 2 times angle at circumference, right? So the nice thing is that now we both know the fact that both angle M1, they both equals to that. So we can equate it. So that means the fact that angle L4 plus angle L3 is equals to angle 2 angle L3, right? So again, in red, I'm gonna remind you what we're proving. We're proving the question, we're basically proving that angle L3 is equals to angle L4. Just remember that that's what we're proving, right? So with that said, is that now, right, we know the fact that we can take angle L3 to the other side. So angle L4 is equals to 2 L3 minus L3. So therefore, angle L4 is equals to what? To angle L3. So we've proved the fact that angle L3 and angle L4 are equals to each other. So therefore, we can conclude that Ln bisects OLR. So now we have proven the question. Hope that makes sense. So now we're going to move to 10.2, right? So with 10.2, it says in the diagram, O is the center. So we see the fact that O is the center. So with O being the center, we see the fact that can we do any properties that are related to O? So we see the fact that we have the following. So we know the fact that if O is the center, so we can't draw a diameter, right? We can't draw a diameter because there isn't any alphabet that they gave us there. So because of the line extends till C, so there isn't any properties related to the diameter. Then again is that you see the fact that okay, the only thing that we know is that this is ratios, right? And we can't draw that one, so we can't draw that one. But the only thing that we know is this one, from here, right, is that this is the center. It goes and it cuts the chord, right? And when cutting the chord, meaning this is going to be 90 degrees. Do you see the fact that this part here is going to be 90 degrees? And reason for that is theorem 1, right? So from there is that in red, I'm just going to write the properties quickly, is that we know the fact that angle B R, right, O is equals to 90 degrees, and I'm just going to say theorem 1, right? I'll just write it the property, the theorem, but it's theorem 1, is that a line going from center cutting the chord, it cuts it at 90 degrees, and also meaning the fact that they're equals to each other, as we can see here, right? Then yeah, that's it. And then from the information again is that the only thing that I can see in terms of like properties wise, right? So let me just put in the 90 degrees here. So I'll put in the 90 degrees, right? Another thing is that, do you see the fact that in this big triangle, right? Do you see this triangle, right? Since we have parallel lines, is that this is going to be the proportionality theorem, right? So we can use the proportionality theorem on the yellow triangle. I think at most reading the information, that's the only thing that we have, right? So hope that makes sense, right? So there isn't much. So that is why I already have one of the questions, because of that's so far what we have so far, right? So now let's read the question. So let's do the first question. It says prove with reasons that triangle. So we're gonna highlight the first triangle, which is C F O, so it's CFO. So this triangle, right, is what is similar to which triangle? So I'm going to do it in green. So it's going to be this triangle, which is going to be CBD, right? So it's going to be this one. Yes, right? So we're gonna prove the fact that the yellow triangle is similar to the green triangle, right? So with that is that we're gonna say what? So we're gonna say proving that. So we're gonna say in triangle. So in triangle. So we're gonna write it exactly CFO and triangle CB. Right? So now we know the fact that this is going to be common, but we see the fact that we have what? We have parallel lines, right? So meaning the fact that this one is going to be equals to this one because of corresponding angles, and also this one is going to be equals to this one, which is corresponding because of the parallel lines, right? So now we know the fact that the first reason, you need to have in total 3 reasons, right? So the first reason is going to be that angle C is common. Then the second one is that angle, and we're gonna name it, right? So we're gonna name it. So it's gonna be CFO, right? So it's gonna be CFO. So it's gonna be angle CFO is equals to angle what? Is equals to angle CBD, right? So it's gonna be equals to the angle CBD, right? And our reason for that is gonna be what? Corresponding angles. So it's going to be corresponding angles. Always write your parallel lines that BD is parallel to what? To FO, right? Hope that makes sense. Then now we're going to move to the third one, right? So the third one is going to be what? It's going to be the remaining angles. So it's going to be what? It's going to be COF. So it's going to be COF is equals to what? Is equals to, sorry. So it's equals to CD B, right? So it's going to be C, D, B, right? So the nice thing about doing this is that your reasons, I think the easiest one is that if you already proved the fact that there's 2 angles there, is that using sum of angles on a triangle, that could be the last one, right? So I'm going to use that one, or you can say corresponding angles. It really doesn't matter. But I'm just saying next time, let's say you're proving that 2 triangles are similar, the goal is to find 2 angles that are equal to each other. Then the remaining one, you can just say the fact that that's going to be sum of angles in a triangle. So sum of angles in triangle. So that's the nice part. If you find 2 angles equals to each other, The other one, you just can conclude the fact that they're equals to each other, and the reason for that is some angles in the triangle. So therefore, this concludes that triangle CFO is actually similar to triangle CBT, and the reason why is angle, angle, angle. And that's how you would answer this question. So now let's do 10.2.2. So it says given that RDO, so let's find that angle. So RDO, so it's going to be R, what you call this? R is here, right? D O, so this angle here. So given the fact that this angle here, so let's make it a red. So this angle here, right, is equals to which angle? So this angle, which is FCO, so it's equals to this angle, right? So what do we see? We see the fact that opposite angles are equal. So that means the fact that this whole line, and I'm just going to emphasize it in red, right? So this whole line, this line, right, is equals to this one. So that two are equals to each other. And the reason for that is going to be what? It's going to be opposite angles equals, meaning the fact that because this creates a triangle. Let me just show you. So this is a triangle, right? So it means the fact that opposite angles equals, meaning opposite sides equals, right? So that's what we have. So we know the fact that now, let me just write it here, that BD is actually equals to what? 2 BC, right? Because of opposite angles equals, opposite lines equals, right? Hope that makes sense, right? So now with that out of the way, then they say show with reasons that OF multiplied by CD is equals to CO multiplied by BD, right? So what I'm going to do is the following, is that I'm going to take a different highlight. I'm going to take maybe orange, right? And highlight the parts that they're talking about. So this is what I always do, is that whatever the size, do you see what I want to prove? I always highlight the side that they're talking about, right? So let's do that. So where's OF? So OF, so OF is this line, right? So it's that line, right? OF is that line, then CD is equals to this line, so from here till here, so that's our CD, right? So we have this sorted out, we have this sorted out, right? And then again, they want what? They want CO, so CO is CO. Also, okay, so OF, then this is going to be CO, so CO is going to be this side here, right? So that's sorted, right? And lastly, BC, so it's going to be this side here, right? So it's going to be this side, right? So looking at it is that we cannot use what the proportionality theorem because of this line. Do you see this one? The one that's part of our question is the reason why we can't use proportionality theorem, because of if it was just sides, right, and this is not involved, then we were going to just go straight to proportionality theorem, but we can use another one, which is similarity. And I think I did something similar in the previous question. Let me just go up. Remember in the first question, we did exactly the same thing, right? Pulling up the two because of the ones that are at the bottom was the one that we wanted to prove the ratio, right? So I'm doing the same thing, is that I'm going to pull out the two similarity triangles so that I can be able to match everything to each other. So we cannot use the proportionality theorem because of this line. So meaning our next option is similar, what you call this, the similar triangles, which we already proved in this question. Hope that makes sense. So I'm going to pull them out, right? So I'm going to pull them out. Remember, we made the small one yellow and the bigger one green, right? So let's do that. So that's what I'm going to do, right? I'm going to pull them out. So let me do that. So we're going to make this one yellow. So this is going to be yellow, representing the small triangle, right? And the bigger one, we're going to make it green, which will representing the bigger triangle, right? So I'm going to name them, right? So naming them, we know the fact that the small triangle is C. It's what? So it's C, right? CFO, right? And the bigger triangle, we know the fact that that's CBD, right? So let's match the angle. So we know the fact that U and U are equals to each other. This and this are equals to each other, and lastly these two are equals to each other, right? So what are we looking for? Remember the fact that from the diagram we already highlighted them in orange what we're looking for. So now I'm going to do the same thing here, right? So matching it up. So we know the fact that here we're looking for what? We're looking for OF. So OF, so it's going to be this one, right? So I'm just going to do it twice so to check the fact that I've matched it up. Then we're looking for CD, so CD is this one, right? So meaning it's this one is done. So we're looking for CO, so CO is this one, right? So it's this one. And lastly, we're looking for BC, right? So BC is going to be this one, right? So it's going to be this one, right? So now, right, is that we see what? We see already that OF, what we want here. Do you see the fact that what we want here, right? OF matches up with BD, right? And we see the fact that because of its tick and tick and cross, so that's perfect. And we see the fact that CO matches up with CD, right? But who does this match up with, right? So we know the fact that, so let's write it down. So we know the fact that OF, so we know the fact that OF, right? And OF matches up with what? With BD. Even though we do not have BD here, right? That is its match. So this matches up with this, and this we do not have any side for it. Hope like we don't have it here, right? So we're gonna come back and sort it out later. So we know the fact that this matches up with this. Then now we know the fact that this matches up with this because there's a dot and a cross. So this and this matches up, right? So we know the fact that this is going to be equals to what? This is going to be equals to CD, right? CD matches up with C. So let me just do this. Because OF is from the small one, so CO matches up with CD. Hope that makes sense, right? And the reason from this is going to be what? This is going to be that the two triangles are similar, so it's going to be that triangle, what you call this triangle CFO. It's actually similar to triangle CBD. Hope that makes sense, right? So now is that when we cross multiply, we see the fact that OF, right, is multiplied by CD, which is we cross multiplying, and CO multiplied by B. We see the fact that from our question, right, to what we want, right, let's take off what we have. We have this, right, and we also have this, but the problem is this, right? But the nice thing is that you see the fact that the BC that we want and the BD are actually equals to each other. But we know the fact that we want BD, so we know that BC, sorry, is equals to BD, right? And the reason why is opposite angles, opposite sides. Hope that makes sense, right? So our reason for that is going to be what? It's going to be sides opposite, equal angles. Hope that makes sense. So I can replace my BD with BC. So therefore, I know that OF multiplied by CD is equals to OC multiplied by BC. And you're done answering this question. So now doing 10.2.3, it says it is further given that DC, so let's highlight. So it's further given that DC, so DC is this whole thing. We given that that is equals to what? It's equals to 19.2 units, right? And they also tell us the fact that BD, so is BD, so we see the fact that BD is this whole thing, right? So BD is this whole thing here, right? So BD is from here till here, right? And they gave us the fact that that is equals to 12 units. And since this BD is divided into two parts, right? So it's divided into this two parts, right? And they both equals to each other. So half of it, meaning this is going to be 6 units, and also this is going to be 6 units, right? So we know that, right? Because that's 12, meaning 6 and 6. Then they tell us the fact that RO divided by RD, so it's the ratio. So that, and I'm just going to change the color, I'm going to make it in red. So representing the ratios, we know the fact that 3 over 4, so RO is going to be 3 here, and RD is going to be 4. So the ratio of that is 3 over 4, which I put it down in terms of ratio, right? Then they say prove with reasons that BF, so I'm just going to highlight what they want in yellow. So we need to prove that this is equals to what? This is equals to 75 divided by 16, right? So that's what we have. Remember the fact that BD is equals to BC, right? Because opposite angles equals from here, right? Opposite angles equals, opposite sides equals. So we also know the fact that this side, and I'm just going to make it in green, I'm going to make it in red. So we also know that BC is also equals to what? To 12. So we also know the fact that this is also equals to 12 units. So this is equals to 12 units because opposite angles equals, so because these two angles are equals to each other. Hope that makes sense, right? So the goal is to find the yellow part, right? So finding the yellow part, this is what we need to do, is that, do you see the fact that this whole triangle, and I'm just gonna highlight it in, maybe let's emphasize it in blue, right? Do you see this whole triangle, this one, right? This one that I'm emphasizing now. Let me just do it properly. So this one, having parallel lines, right? Do you see the fact that this triangle, right, having parallel lines, is that we can use proportionality theorem, right? So meaning that using the proportionality theorem, I need what? I need the following. I need to basically find the units, right? We already have the units of BC, right? And we want the small part, right? So using the proportionality theorem, so I'm going to just write it using the proportionality theorem. We know the following. We know that BF, right, divided by the part that they gave us, right? So from here is that BF, then the denominator is the part that they gave us. We know the fact that this, right, this BC, right, because we already know that it's 12. So we know the fact that BC, right, and it's going to be equals to the other side of the parts that they gave us. The nice thing is that they gave us this long part that matches up with BC, right? So meaning BF from here matches up with this one, which is BO, right? So it's going to be DO, right? And divided by the whole part, this part, right? So this whole part here, which is B, which is DC, right? So it's going to be DC, right? And we know the fact that this is going to be proportionality theorem. And we know the fact that FO, sorry, is parallel to BD. Hope that makes sense, right? So we gotten that out of the way. The reason why I'm saying I'm using the parts that are already given is that I know the following. I know the fact that already BC, I have it as 12 units, right? I also know the fact that, so let me go down. Given, I know the fact that given, let me write it down. I know the fact that the things that I'm given is that I know the fact that BC, right, is equals to 12 units, right? And I also know the fact that BC, sorry, is equals to what? Is equals to 19,2 units. So to basically solve for BF, which is what we're looking for, what do we need to do? We need to basically calculate DO, right? So where is DO? DO lies on this small triangle. Do you see it lies on the small triangle, this one, right? The nice thing is that that triangle is 90 degrees, and we also have the ratio of this. Do you see the fact that we have the ratio of RO and RD, right? Meaning I can find what? I can find DO because of using the ratio is that I can find what RO is, right? Meaning I'm gonna have the fact that this, I already know the fact that this is 6. I already know this is 6, and using the ratio is that I can calculate what this one is using the ratio. And now using theorem of Pythagoras, since this is 90 degrees, remember when I said theorem 1, it's going to come back, is that I can calculate this DO. Hope that makes sense, right? So now we're going to do that, right? So we're going to start with what? With calculating RO, right? So RO, so we know the fact that the following, we know the fact that from the given information that RO, we know that RO divided by RT is equals to 3 over 4, right? But we also know the fact that RT is equals to 6 units because of they already gave us that this one is 12 units. Hope that makes sense. We already know the fact that this is 6 units, right? Because of the fact that they both equals to each other. So half of 12 is 6, right? So we know the fact that RT, so we know the fact that RO, then this is going to be 6 units, and this is going to be equals to 3 divided by 4. So meaning we can calculate RO. So cross multiply, so it's going to be 4. RO is equals to 3 multiplied by 6 units, right? So now divided, so it's going to be RO is equals to 3 multiplied by 6 units, right? Divided by what? Divided by 4, right? So now with that said, is that now we can calculate what? We can calculate RO. So therefore, putting that in the calculator is that RO is going to be equals to what? To 4,5 units, right? So we already know the fact that this is going to be 4,5 units, right? So now with that said is that we sorted that out. So now what we're going to do is that we're going to calculate the following. Sorry, before calculating the following, I need this to be organized. So I'm going to just copy and paste this one, right? And put it here. Yes, right? So now we have ROS being 4,5, right? So now we're going to calculate the DO, right? Which is needed from where? Which is needed from here, right? By DO, we're going to use theorem of Pythagoras. But before using theorem of Pythagoras, is that we need to state why we say this is 90 degrees, right? So we're going to do that, right? So we're going to state that first. So we're going to say O OR, so OR, right, is parallel to what? Sorry, is perpendicular to BD, right? So we basically stating that this line is perpendicular to this one, right? And the reason from that is that the from theorem 1, which is the proper reason, is not necessarily theorem 1, is that it's line from center, right? Line from center to midpoint, meaning midpoint it cuts the two sides, midpoint chord. So this is theorem 1, right? So line from center to midpoint of chord. Hope that makes sense, right? So now with that said, is that now I can find what? I can find DO, because DO is the hypotenuse and that's a right angle triangle. So we know the fact that DO squared is equals to what? It's equals to the other side's equal, right? So it's equals to RD squared plus RO squared, right? So this is what I'm saying. I'm saying this side is equals to this and this plus them, right? So we know the fact that the reason for this is going to be Pythagoras. So our reason here is going to be Pythagoras. So it's going to be Pythagoras, right? So now we know the fact that we're looking for DO squared is equals to RD. Remember, go back. RD is equals to 6 units, right? So it's going to be 6 units. So this is going to be 6 all squared plus RO. We solved it as 4,5 all squared, right? So this is going to be DO square root both sides. So it's going to be the square root of 6 squared plus 4,5 all squared, right? So therefore DO is going to be equals to what? Our DO is going to be equals to 7,5 units. So now we have that, right? We have DO equals to that. So now going back, remember the fact that this is what we're going to be using. So I'm going to copy and paste this one because we already know what DO is, right? So I'm going to put it back here again, right? So now we're going to substitute everything that we have, right? So we know the fact that F is what we're looking for. Then we know that BC, remember going up, we know that BC is 12. So we know the fact that this is going to be 12. And we know the fact that DO is 7,5. And finally, we know that DC, remember, it's 19. It's 19 comma 2, right? So we're going to cross multiply. So let me just do that. So when we cross multiply, we have the fact that BF is equals to 7 comma 5, right? So this is going to be 19 comma 2, right? Multiplied by BF, and this is going to be multiplied by 12, right? So therefore we know that BF is basically equals to 7 comma 5, right, multiplied by 12, and this whole thing divided by 19 comma 2, right? So you punch that into the calculator, you find the fact that this is multiplication. Let me just do that, right? So we find that when you punch that into the calculator, you get that BF is basically equals to 75 divided by what? Divided by 16 units, which is exactly what they said we should prove in the question. Hope that makes sense. Okay, now 10.2.4, it says calculate the angle ABC. So it's A, so it's going to be A. So let me take my highlighter. So it's going to be A, B, right? And D. So we're calculating which angle. So our goal is to find this angle, right? So that is what we're looking for. So let me just make it in red. So we're looking for this angle here, just here, right? So that's the angle that we're looking for. So basically, I've just filled in the triangle. We already know that that's 6 units and this is 4,5, right? So that's perfect. So using that is that you see the angle that we want B is that the relationship that we can use to find the angle is the following. Is that angle B is an exterior angle of this triangle. So I'm going to highlight it in yellow, right? So do you see this triangle here? Let me just do this. This triangle. So I'm just going to do it in yellow. So this triangle, right? So do you see this triangle? Angle B is exterior of this of that triangle. So meaning the fact that angle B, so we know the following. We know the fact that angle B, right, is equals to 2 times angle C and angle D, where there is dots. So this angle is equals to 2 times this 2, right? So what is the nice thing about that 2? Do you see the fact that this one is in this small triangle, meaning I can use trig ratios to basically solve this because I have 2 sides, and since these 2 are equals to each other, when I add them, this is going to be equals to this. Hope that makes sense, right? So first thing first is that we're going to basically establish how angle B is equals to this 2, right? So we're going to say angle, the angle that they want, so it's angle ABD, so it's going to be um, ABD is equals to what? So we know the fact that angle ABD is equals to angle C plus what? Angle, let's name it, so it's going to be B DO, right? So we know the fact that that's equals to that. And our reason for that is what is going to be exterior angle of a triangle. So it's going to be exterior angle of triangle. Hope that makes sense, right? So now solving for this angle, we know the fact that we can solve this 2 angles that we want by using the what you call this, by using trig ratios here, right? So we see the fact that we have this angle, this is the one that we want, and opposite over what? Over adjacent, so this is 10, right? So I can solve this angle here using that, right? So using that, so we know the fact that solving BDO, right? We know the fact that that's going to be 10 of that angle, which is going to be BDO, is equals to opposite of that is RO divided by adjacent, which is RD, right? So now we know the fact that this is going to be 10 of BDO is equals to, we already know the fact that RO is 4,5, and its RD is 6, right? So it's going to be arc10. So BDO, because we want the angle, is going to be arc10 of 4,5 divided by 6. So we know the fact that BDO is basically equals to what? So punch that into the calculator. We're going to find the fact that this is going to be equals to 36,87 degrees, right? So we know the fact that BDO is equals to what? Is equals to 36,87, right? So, but we know the fact that angle BDO is equals to angle what? Angle C, right? Is equals to angle C, right? And you can just say the fact that this is proven because we already proven that, or it's actually given. It's not proven, so this is actually given, right? Remember the fact that one of the informations, let's go back. Um, it was actually given here, right? Hope that makes sense. So now, with that said, is that we can conclude the fact that the angle that they want, which is ABD, right? So I'm just gonna copy this, right? So we're gonna do this since that two are both equals to, since these two are equal, so that means the fact that angle ABD is equals to 36,87 plus another 36,87 because they both equals to each other. So therefore ABD is basically equals to what? It's equals to, when you add them together, it's 73,74 degrees. And that's how you would answer this question.